We would like to recognize them. I don't want to start naming them, but it would be good that we give people the opportunity to introduce themselves so that we know who is who. I can start from my right. Gentlemen, if you don't mind, just say who you are. Sorry, from the Minister of General Resources. Yes, you can just say who you are, the position that you hold, and which institution. Communication organization specialist. Very good, thank you, sir. Yes, yes, please.
Good morning, everyone. My name is Fabrice Mugabo. I come from WRI, which stands for the World Resource Institute. From the climate change program, working as an adaptation advocate. Thank you so much.
Very good, sir. Welcome.
Good morning. My name is Veronica. I come from Rwanda Environment Management, the former panel, the judgment and information.
Good morning. I'm Tita Somoro, working with the Development Bank of Rwanda. I'm the researcher.
Thank you. Good morning, everybody. My name is Miguel from the original Petra from West Rwanda. I'm a professor in the Department of Forestry, which I'm heading. Thank you. Happy to have you.
I'm Luis Homana from National Council for Science and Technology and the Department of Science, Technology, and Development.
Thank you very much. Let's start from here. We'll take it out.
Yeah. Thank you. Thank you. My name is Gita. I work for Academia 2016 as a director for the Operational Analysis Department and coordinator of this CACCI program.
Thank you.
Thank you. Hello, everybody. My name is Masul Jah. I work at Academia 2016 as an associate research scientist specialized in data science and machine learning.
Good morning, everyone. My name is Ambaria, Associate Research Scientist in Academia 2016. Thank you. Thank you.
Good morning. My name is Enrique Saimano. I work for the Rwanda Environment Sources, but as a data engineer specialist.
Good morning. Wilbur Osman, National Research Department.
Welcome.
Okay, thank you. I'm Mari, and I work at one space agency as the division manager of Earth and Space Science.
Welcome, sir.
Good morning. My name is Etienne Niga. I work for CNFA. We are implementing a USAID-funded project in Gawungu. I work there as a climate and resilience advisor.
Thank you very much. Thank you.
Good morning, everyone. My name is Nadia Karimera. I work for Rwanda Space Agency as a scientific analyst.
Hi, everyone. I'm Pedro. I work for Academia 63 as a intermediate station.
Thank you.
Good morning. My name is Eshen. I'm working as an IT coordinator at Academia 26.
Let's end here, please, sir.
Yeah, good morning. I'm David Inika. I work with Soil Group, the climate change advocacy.
Good morning. I'm Jean-Claude from CCAB, Executive.
Welcome, sir. You are all welcome. It is a pleasure, as I mentioned, to welcome you today at the Comprehensive Action on Climate Change Initiative, the CACCI. As you can see from the planet there, we still have the previous name of the initiative. That doesn't really make a big difference. You all appreciate the journey that we have been through so far. So today we are having a knowledge seminar, an important activity. I guess you are here because you think it's important for all of us to come together and share what has been like running or traveling together on this journey. What is the budget of knowledge that we were able to co-create, and going forward, how can we put that into use? Before we go further into the agenda, you all have received it, and you'll be given an opportunity to make some comments if you think there are some concrete elements that are missing that might help to improve our proceedings of today. So I'm happy now to invite our MD, Dr. Muni Savadogo, to share some welcome address. And from there, we'll invite Eric to do the same. Dr. Muni.
Thank you very much, colleague, for the opportunity to give welcome address at this occasion. As you rightly said, this is a knowledge seminar, but I would like first to really appreciate your presence, each and every one of you. Thank you for honoring the invitation and being here. And I would like to especially thank our colleague Eric and the entire team of REMA for co-organizing this knowledge seminar with us and facilitating also the work that we are doing together under this CACCI, the Comprehensive Action on Climate Change Initiative here in Rwanda. I also would like to put it a bit into context. As Academia 2063, as you may know, our vision really is to bring the expertise we need for the Africa we want. And this is really also, of course, translated into what we know here as the Rwanda we want. And we would like really to appreciate the opportunity given by the government to also contribute to the vision that have been shaped towards 2050 here. Vision that is a bit encapsulated into three main enabling pathways that are human development, competitiveness and integration, agriculture and wealth creation, urbanization and agglomeration, and accountable and capable state institutions. These are very key, of course, but as you know, not only that climate change is challenging us, threatening us, but is rightly now seen as a real crisis that is exacerbating our existing challenges and sometimes jeopardizing our effort towards the ambitions that we are fixing and targeting. And you know also that climate change is a cross-cutting issue. It means that all the enabling pathways that have been defined under this vision, they all are affected in a way by climate change. And that's where we really want to thank the government for the opportunity for us as academia to bring in our expertise in data analytics and new technologies that can effectively contribute to the vision. Specifically, our contribution, of course, is embedded into the green growth and climate change strategy of the country. And within that, we are specifically looking at the sustainable land use and natural resource management aspect of that strategy. And our technical support focuses specifically on this thematic area 3. And the objective here for us, as I said, is to bring in and contribute to the provision of data and analytics for evidence-based decision and implementation for effective investment programs. You know how important it is to have appropriate data at the appropriate level, and how bringing analytics to that can generate information and knowledge that can make projects and programs as effective as possible and make the desired impact. And that's why we think that is very important. And this seminar is so crucial in terms of, for us, after a year of implementation of this initiative, that we bring to you as partners the approaches, the methodologies, the findings that we have together right now, bring them to you, share with you, discuss with you, so that we have the information, but also together with you and see how best we can look forward into further contributions to the climate change action in terms of helping the country to accelerate its climate actions and then at the end contribute to the global vision of the Rwanda we want. So CACCI is a joint initiative with facilitation and technical support from Academia 263 and then another organization, ANAPRE, you may know. But here, Rwanda and Senegal, Academia 263 are responsible of implementing that as a pilot countries. And then based on that, we know that CACCI has been extended beyond Africa now, touching also other continents. But we got a lot of lessons through the implementation here in Rwanda, and this is an opportunity to share them. So the objective here is to present and discuss the CACCI analysis that's made here on climate risk, vulnerability, the country status assessment impact, and then mitigation and other pathways, adaptation pathways, and then facilitate. Mutual here is about mutual learning. This is all about mutual learning, and we want to share knowledge. We want to together make sure that we approach the climate change here in the best way by bringing together our expertise and effort. So, Eric, I would like to thank REMA very much for the good collaboration. We want also to thank very much USAID, who is providing necessary funding for this project. And then for all of you as our partners here in Rwanda, helping us and bringing the opportunity for all of us to work together. Thank you very much, and I look forward, considering the diversity, considering the expertise in the room. I really trust that at the end of this seminar, not only that we will get a shared knowledge, but also we will learn and we will deepen our knowledge and our visions also towards the future initiative and actions we would like to take to continue to support Rwanda programs. Thank you very much for your understanding.
Thank you very much. This is really inspiring. We would like to invite Mr. Eric Odakiwa from REMA to please share some welcome remarks.
Thank you. Good morning, everyone. As you say, my name is Odakiwa Eric, and I'm working with REMA's project manager. I also share my gratitude toward the academia on behalf of REMA on the opportunity they gave us to make up on MOU to implement the CACCI project. This is we had different outcome to the deliverables in the MOU, and I hope today we'll be having a few of them responded and then learn from that, so that we can come up with some of the objectives follow up in our process of implementing the CACCI project and implementing our climate change action plan. So it's a very good room represented by a lot of institutions. I was not prepared for this sincerely. Looking on the invitation, the academic sent us. They requested us with the list of all of our institutions. Almost the half of my institution is there. But unfortunately, some of them will not have other duty they are busy. But I'm glad to have almost everyone in the room. And I think the CACCI, this conference, if I say seminar, will bring up different capacity, different knowledge together so that we can tackle the objective of the CACCI, the objective of our guidelines, and then our programs. So, looking on what we, on the first time when academia came to REMA, they presented us the idea of what they can do for us. They can support with the Rwanda institution. First of all, they have a bunch of knowledge of people who are dedicated on research on activities such as what we are going to learn today, because this is a knowledge seminar, as they say. So I assume I don't know what is happening. We'll be learning. On myself, I will be learning for sure. Having all of these figures in room, it's a lot of knowledge in the same room. But I also expect academia to be impressed by the people coming in this today seminar. So in the MOU, we're targeting to, depending on what we have on our NDC and our capacity, as REMA is one of the institutions to track the implementation of NDC, and then to understand and then to know how we can support the implementation of our NDC toward our target. Then in the MOU, it was one of the ways of understanding, collaborating with the knowledge that is in academia to make sure that some of the gaps you have, some of the activity you cannot do, but academia has that capacity. We can initiate this kind of discussion and then support on this, and at the end we bring up different institutions to give their point of view on what we have, what we can do, and when we can improve. It is also a very privilege, as Dr. Mlim said. Academia has his headquarters in Rwanda and Senegal. So it's really a good opportunity to have them and then work with different institutions as they invited you guys on to really understand. They are not the kind of people they will leave the countries. They are here. I think you're not moving your quota soon, so that we can still engage with what you have and what you are planning to do with the different sectors. They are really very much in culture, mainly with the Ministry of Agriculture. But I think all of it's all about the deliverables and our climate change action, as you mentioned. It's also the way to support data gathering, data analytics, as they say, in different areas. So one of the areas we really have gap in climate change, it's data. So how to gather data, how to understand our data, how to request our data, how to invest data. Those are the kind of, and the tools as well. So we have different tools that we may use. Most of our stakeholders or Rwanda government institutions, when you look on our MRV framework, there is some data we need to gather. There's some of the study we need to do almost every year as mandatory on, for example, availability index assessment. There are some of there's a study we need to do. But what else we want to understand on our NDC? Does it impact our economy? It's just a number to say, okay, we reduce the GHG emission. Did we reduce the pollution? Did we reduce the air quality? Did you measure what is happening? But what is the impact of this climate change impact and getting to have been reduced on our economy? So that is kind of the we know that the academia could do that, and I think we saw it on the agenda. There's some of the deliverable we had on the CACCI MOU about this. So I think we will be having much to understand what we are doing now, and then to support our government and our institution to tackle most of these targets that are almost difficult for some of us. If we need, when we need data, for example, some of our people, for example, today they don't understand what is the MRV framework. But bringing hope the how we track on this to understand what was the aim of this, how do we put all the deliverables and see how we can reframe them to be one kind of target that coming from different source of document, because there is a target in Minagri, there is a target for the space, there is a target on different institutions, but how can we bring them to make them easy and then compile some of the data? It is still a very long way to go, but I think that is the beginning where we should go and then understand. And as well, have these people in yeah, maybe we have as they say to learn different some new tools that will help us to understand what we have been doing, and then from this perspective, and then start with everyone interested. Say, okay, I'm interested in this. I'm interested in this. How can I develop it with the academia, with the person? So, saying so, I really appreciate this academia work so now, and then we appreciate as well your presence here and support this, and then I hope we'll bring more on the table, not just listen to what academia has to present us, but I think we'll also improve conceptualize this result and what they have been doing on Rwanda scale specifically. So thank you very much, and we hope we have a very fruitful day.
Thank you very much, Eric, for those words. We much appreciate the collaboration with REMA so far. It has been very productive. I would like to now invite Mr. Gitao, who is the project lead from Academic 2063 and director of the to present us with the objective of the seminar and help us set the scene.
Thank you, Augustine, and thank you for everybody for coming. And we have some additional partners here. So I invite them to introduce themselves because this from the Ministry of Environment is from them. So because we introduce ourselves.
Oh. That's I'm sorry. Good morning, and my name is Paul Mercy. I work with REMA in the climate change program. We coordinate climate change reporting projects and initiatives on cost building, those kinds of concepts.
Good morning and welcome at Academia. I'm Serafino Senga, work for Academia as a country coordinator, but also as a senior scientist in the Department of Policy Innovation. I know many of you work together. I'd like to reconnect here. Welcome.
Good morning. Sayman, I work with the Ministry of Environment and Child Environment Policies. Thank you.
Good morning, everyone. I'm Innocent Alexander. I work with JZ Rwanda under the project NDC Capacity Development as a technical advisor.
Thank you. Thank you. I think we are very much glad to have you here. And I will be briefly presenting what we are going to present and what's the objective of this seminars and all these things. You know, there is always a challenge that's in the research arena. When you write a proposal, it's really very attractive and it looks nice. It's the same as like seeing the 3D of the house. Just like when you see the 3D of the house design, it looks very, very appealing. But finally, when you just implement it and conduct it and then find the result, and somehow that's the saying, there is a saying that the proposal looks like a horse and the result looks like a camel. That's it. The camel is just, the idea was to construct a horse, and then we end up to have a camel. That's how people are saying. But in any way, we did our best to come up with some data and analysis on this project. As we have repeatedly said that this is a pilot project. A pilot project which has been initiated in Africa, and we are very much happy that it has not become a global program of USAID, but it was really started in Africa with Academia 2063 and RENAPRI, which is the Regional Analysis Network agricultural policy research networks. I mean, it's based in Zambia. So again, I think that's why we changed A from Africa to actions. I don't know, this way. Yes, I think it's a global now is an initiative to support countries implement their climate change commitments. That is the whole idea. Please come, welcome. Yeah. And most of in many cases, many countries in Africa, almost I think 53 or 52 out of the 54 countries, they have the NCCs and they have deleted for the UNFCCC. And most, about 17 countries from Africa, they have the national adaptation plans. And they have submitted for UNFCCC. So even in other countries, even including Rwanda, we have our own local initiative, also climate change strategies like the DG. So I think the whole idea is to support this implementation of all these policies and programs in the country through data and analysis. You know that the technical support requires a lot of involvements, and you know that climate change is a very complex subject. But we just want to contribute only on the data and analytics. In Africa, we started it and it has been launched in COP26 in collaboration with the African Union. And it was piloted in 4 countries. Rwanda is one of them. Rwanda, Senegal, Zambia, and Ghana. And we also support at continental levels, and we work closely with the African Union because the African Union has also its own climate change strategy and climate change resilience development strategy. So they want to implement, and we are supporting them, and we are trying to develop a tracking tool for them to assess implementation of that strategy across the member states. So this were more about it, but generally the objective is just facilitate the implementation of NFCs and NFPs. Basically, then we focus on 3 areas. We help for countries to better target their investments. Climate change action. So climate action is all about investment. We need investment in different areas for mitigation as well as for adaptation. So how best we target our investments so that we can provide the best result that we can. And the other one is just measuring performance. Once we do something, once we do some capacity building, implementations, and all these things, we have to track our performance in terms of, reducing greenhouse gas emissions, reducing, adapting to risks, and also building resilience and all other issues. And then the third aspect of CACCI is mutual learning. This is part of this seminar. So we have some knowledge sharing different stakeholders and all this. So we facilitate. We have been organizing different discussion forums and policy dialogues at different levels, including this room. I think many of you have been here for some times. And we have been also organizing some seminars in COP27, COP28, and COP22. So these are part of that program. I think this is how in Rwanda we launched CACCI in 2023. On January 23, almost a little bit 1 year. And in between, we have also discussion in the same room where we have people from the Ministry of Environment and Rwanda Space Agencies, and all people are here. So then I think this is the third time we meet, the launch in 2023. Then today we will be presenting what we have done since our launching in 2023. So what we did is in Rwanda, the first thing that we do is we try to review the available policies and the M&D systems which are very much related to the climate change. So we review different documents, different systems, including MRG, the ML, and the NRS and MIS, and all this. And then we try to develop an integrated result framework where that brings all these M&D systems together. And as Eric said, we need to do a little bit further and explain what that means, this integrated result framework, and what can help for guiding their action and all these things. So this is the first activity. And the second one is we try to assess the country status and the progress in terms of different aspects. For example, on tracking methane, how to really track methane gas emissions. And also in terms of climate risk mapping, we did some climate risk mapping, and we did also vulnerability assessments, and also tracking adaptation actions, because it's really very difficult to track some of the adaptation actions. it's easier maybe to track the vulnerability status and the risk, but actual activities on the ground, tracking the actual activities on the ground is somehow a bit challenging and data intensive, but we tried our best a little bit to come up with some baseline information. And the third and most important one, and we will have discussions, especially for those who are coming from different institutions like the banks, and also from with some economic backgrounds. And here we did some mitigation adaptation pathways. What we did here is the impact of climate change and adaptation actions, how really climate change affect the GDP of the country, the investment, the employment, and the agriculture sector and the non-agriculture sector in terms of agricultural value additions and all these things in terms of poverty as well. So we try to estimate some of using some economy-wide estimation models. So we have an expert with us and who will be presenting on this. And also we looked at the mitigation pathways. I mean, Rwanda has committed to have some level of conditional and unconditional level of reduction in mitigation by 60% and 22%, 38%, 38% together. And then what does it mean in terms of economics? I mean, in terms of like overall economic performance, what does it mean? I mean, how really achieving those mitigations affect our investments, affect our economic growth in agriculture, in non-agricultural sectors, and all these things. So we did some analysis and we will be presenting those things. So these are some of the things that we'll be talking about. And so I don't want to take too much time because there will be every expert will present their research outputs and then we'll discuss about it. I'm sure you will grasp some of the concepts and some of the policy implications, but this will not be the last, and we will continue having a series of capacity building activities and a series of engagement so that we'll be more clear about the findings. And the whole objective of this seminar is to just present and discuss about our preliminary findings, and also, as I said, participate some mutual learnings. So then I think in terms of the programs, I think we are already a bit late, but the next program will deal about methane tracking based on remote sensing, and our friend Racine will be presenting on that. And then we'll have spatial distribution of climate risk using remote sensing. Mansour from our social scientist will present his findings. And after Kofi, we'll have the economy-wide, the impacts of climate change and adaptation actions will be presented by Dr. Henry, and he's with us, and he will present his findings. And then we'll also have some vulnerability assessments that have been done by our friend Samban and our associate scientist at the Academia 2063, and he will present us some of his findings. Then after lunch, we'll continue having the economic impacts of mitigation pathways, and the different pathways, and how which one is the best options, and how those economies are affected by the different targets and all these things. So if we have time, and I will also present some of the climate action staff assessment report that we have started, but that depends on whether we have time or not. But finally, we want to have a reflection and general discussion on the way forward. As I said before, this is a pilot program. We focused on data and analytics. And the next phase has to focus on capacity building, real support on the ground level. So I think we focus on the research findings, understanding the politics, understanding what's going on, and the options and the actions and all those things. So these are some of the programs we have for this seminar. And I think that's all. I think for the presenters will have maybe 20 or 25 minutes for presentation, and they give us some time for discussion after each presentation. And with that remark, I will hand over to the moderator.
Very good. Thank you, Carol, for your presentation. Now, as we saw, we are like 20 minutes down in terms of our time management. We have to try and improve. We have online our colleague, Racine Lee, who's going to make a presentation, as indicated by Gitaro, on the estimation of greenhouse gas emission based on what's the same data. Racine, if you, yes, we can see your presentation. Please go ahead and try and stick to the time to allow for engagement with the audience here. Thank you, Racine.
Thank you so much, Chair. And can you hear me?
Yes, we can hear you, Racine. We're trying to increase the volume for the room. Yes, go ahead, sir. Everything is perfect.
All right, great. Thank you so much. Thank you, Chair, for paving the way. Thank you, Getaw, as well. Dear colleagues, thank you for your time and for being here. My name is Racine, and I work at Academia 2063. I'm going to try to stick to time. And our goal here is to present the first results based on the study we conducted for the two countries where we are piloting CACCI, Senegal and Rwanda. But in this case, I'm going to present the result from Rwanda. This work has been done within the Department of Data Management, Digital Products and Technology, in particular Mansour Jah, who is in the room next to Getaw, I think, and myself. Other colleagues also helping the process. So now my presentation here is a four-fold presentation. We will start by justifying why methane tracking. Then second, I will expose the data and methodology we've been using. Third, the first results for Rwanda. And four, just one or two slides about a short discussion and the next steps that we envision within this project and program. So I'm not going to spend too much time here, but I'm going to share our justification for methane tracking. We are probably all aware that the discussion around climate change mitigation and adaptation have focused for a long time on carbon dioxide, CO2. But recently methane is attracting a lot of attention due to its effectiveness as a better strategy to mitigate global warming faster. And the reason for that is its capacity to absorb and re-emit infrared as other gases, greenhouse gases, but also the relatively short lifetime in the atmosphere, which is around 12 years. For carbon dioxide, it might take longer, much longer in the atmosphere to remove, but the lifetime of methane is short enough for us to consider it as a low-hanging fruit in combating climate change. As an example here, the removal of 1 ton of methane probably will correspond to around 84 to 86 tons of CO2 removals over 20 years, and between 28 and 34 tons over 100 years. This is based on the recent IPCC assessment in 2023. Now here, I'm going to stop on two aspects. The first one, those are the footnotes. So you will find in the literature several here value in terms of global warming potential, which is the metric that is being used to compare the impact of greenhouse gases in the atmosphere and in our climate compared to carbon dioxide, CO2. Sometimes you will find like a global warming potential of 21 is often accepted since the second IPCC assessment in 1995. But the latest IPCC is providing a global warming potential between 28 and 36. So this is a disclaimer just to make sure that I'm sharing that with the audience here. And the change between the two is because of a better understanding of the enhancement of tropospheric ozone and stratospheric water vapor that are also impacting the role of methane as a greenhouse gas in the atmosphere. So now, given that, let's spend a little bit of time on the climate budget globally, and then now how do we project that in the countries where we are applying CACCI? So when you investigate a budget here for methane, so what we realize in the literature is that it appears to have a wide range of natural and anthropogenic sources. So you will have sources that are natural, and you will have sources that will be, let's say, enhanced by human activities. But those sources are balanced with a few and often radiative reinforcing sinks. So radiative reinforcing means that basically the greenhouse gas will increase global warming, and global warming in turn will also increase greenhouse gas. So it's like a circle that will keep going and increasing, therefore, the concentration of a specific greenhouse gas. So here, the very few sinks that we found for methane also have a radiative reinforcing sink. So second, if you look at those sources, how much they are emitting, a year, it's between 500 and 600 teragram, meaning a million of grams of methane per year. But the sinks are estimated to remove between 460 to close to 600 teragram methane per year globally. So if you look at those figures, basically the global community will need to deal only with an exceeding budget between 20 and 52 teragram methane per year. This sounds like a very good news, saying like, okay, we don't have a lot to deal with when it comes to methane. But if we follow such an analysis, this will be misleading because we are not incorporating the impact of global warming into increasing the methane emissions. Those are the famous radiative reinforcing effects that I mentioned earlier, meaning again, global warming increasing temperature and temperature increasing, greenhouse gases increasing global warming and global warming increasing greenhouse gases emissions again. So here an example, for example, of positive feedback for methane would be the methane emissions that depends on temperature and water table depth and substrate availability for wetlands. So wetlands are among the largest emitters of methane. And it is, while we don't know the intricacies and interrelationship between those three parameters, at least we know that temperature is often the dominant factor of the three. So what it means here is if you have like for the same water table depth and the substrate availability for methanogenesis, basically, if the temperature increases, most likely you will also increase the methane emission. So this is a reinforcement impact, feedback, positive feedback of methane. So you already have methane in the atmosphere that increases your temperature, and your temperature will increase your methane emissions from wetlands and so on. Now, when it comes to Africa, the justification here is despite a political will to combat climate change, we can see that in the continental agendas. Still, I think my friend there, Eric, mentioned that several barriers impedes the effective design implementation, and among them, the lack of data. The lack of data about the dynamics of greenhouse gas emissions to inform those policies and interventions. And what's the issue with the lack of data here? Most importantly, it would be like the reporting that might be subjected to inaccuracies. Here, inaccuracies meaning like overestimating or underestimating the budget of greenhouse gases, which having an impact on having a real assessment about what is going on the ground, but also the negotiations that are happening on the global scene. How can we make sure we have a realistic figure of our climate budget, or greenhouse gas budget, or emission budget? So here, our belief personally is that we are underestimating our budget, meaning that we are sinking more than we think, but that needs to be backed up with a lot of data and evidence in our countries, including Rwanda. So just one quote here that we found also in the Global Methane Hub results, that to get to a 1.5 degree pathways, even though now we are seeing more and more in the media and in the literature that we passed this 1.5 degree. And now we are discussing about finding another, let's say, threshold that we need to hold on. About a third of the methane emissions should be eliminated from our current levels by 2030. And also about 45% by 2040. So such a drastic reduction requires contributions from all, including in Africa, even though it is believed that we should focus on adaptation more than mitigation. And such journey should start with a stock-taking exercise of the current level of methane emissions, at least to create a baseline. That's the goal of this first study of tracking methane. And today I'm going to share with you the first maps that we derived from Tropomi, which is the sensor within the Sentinel-5 precursor satellite mission that we processed and used here in this study, something we also already did for Senegal and published in our website. Now, I'm going to switch to the second aspect of the presentation, which is about the data and the methodology, which is as important as the results. Now, here, I just would like to share or maybe put to scale where we are focusing our analysis. Here in the image on your left, you will see the different layers of our atmosphere moving from the troposphere all the way to the thermospheres, and in between you have those transition layers, meaning the tropopause, stratopause, and mesopause. But here, the focus on tropome is the closest layer of our atmosphere, which is the troposphere, which is between 0 and 10 kilometers approximately above ground. And it is believed that us as humans, how we feel it, and our impact in the atmosphere that will get back to us as a positive feedback will have an impact on the troposphere between 0 and 10 kilometers. Anyway, this is the closest layer close to Earth, where we are having an impact and where we are emitting the greenhouse gases. So now this is where we are focusing on. There are other, of course, methodologies and other types of data and models that are focusing on the concentration on other layers, but this is not where we are focusing on for now. Now, once we have the scale, how do we measure the greenhouse gas? I'm going to share here, maybe, I think I already had the chance and the privilege to present this during our board seminar last year. But the idea here is you send a light to a cloud of gas. Some of the light will go through that box of gas, and some of them might be absorbed or reflected. So the first panel here, which is the transmittance in total, it's a value between 0 and 1, meaning how much light, when you send that in the box of gas, will be transmitted to the other side of your box or your gas layer, and how much therefore will be stuck, either absorbed or between the interaction between the molecules or reflected. So what you see here is that those small bumps in the curve means that there is absorption of the light by the molecules, but we don't know what kind of molecules is that. We just know that it's not passing. Now, the two last panels are the molecules that were in that gas. It's the carbon dioxide and the methane. So this is how you can measure the density of the gases that you have in a layer. And imagine now you can transmit or you can transpose this principle into a satellite and start measuring the concentration of those gases. Now, for instance, here, the methane and the carbon dioxide absorb lights in the 1.6 micrometer spectral range, and the intensity of the absorption is the proxy of gases abundance. So, meaning here that our gas layer for the satellite will be a column of dry air, where you will send the light and collect the feedbacks in terms of transmittance, and from there you have an idea of how much of that gas you will have by layer. Now, tropome here, just in terms of flight mission, you will see the flight direction, which is from where you are to where I am, basically from the back of the room all the way to the screen that you are looking at. So there you have a swath of 2,600 kilometers for 1 second of flight, and the width is 7 kilometers. So it means that basically you cover a lot of area with just a 1 second of flight. And once you get to that 1 second of flight, that band that you're collecting the data from, you will have basically a several wavelengths that will be collected and measured. So the size here will be between 3.5 and 7 kilometers of size. It has been downscaled to 3.5 to 3.5 kilometers square at nadir. Nadir is like at the top of your head, basically. And tropome is a passive sensor, meaning like there is no energy in terms of light that will be sent from the satellite to the ground and collect the echo as a radar. It covers the globe entirely and daily, and then the weekly average data are publicly available. Now, still, we need to make the case for what are we sure that what we measure from the satellite is actually what is going on the ground in terms of data validation. Luckily, the tropome, of course, has been validated with some, let's say, stations that are on the ground. So, and of course, you will find a bias between what you collect from the satellite and what is happening on the ground, but there is bias correction that has been applied to the data processing algorithms that is embedded as a payload on the satellite. Therefore, what the satellite will give you at the end of the validation process is the data that has been biased corrected to reflect what you would have on the ground and sensitive to the let's say lower layers of that dry column between 0 and 10 kilometers. Therefore, the concentrations that you measure from the satellite will be sensitive to the lower layers of your scale, which is 0 to 10, meaning that it will be very sensitive to what you have on the ground as emissions. That's why even in the literature, some colleagues are, and in the community, are using the tropomy as a way of measuring emissions completely rather than concentrations. Now, from this spectra here, you see that the accurate and precise average abundance for several gases tropomy provides: CO2, the formaldehyde, you have the nitrous oxide, the monoxide, carbon monoxide, so the water vapor, which is a greenhouse gas. Also, we tend to forget that those clouds are also greenhouse gases, and other gases. But here our focus is on methane. So basically, tropomy, methane, and what we call SLCPs, short-lived climate pollutants as well. Now, further into the data validation process, you will see here on your right, maybe the Pearson correlation between on your x-axis, you have the stations of methane on the ground in terms of concentration, and you have the tropomy measurements from the satellite on the y-axis. And you see that at the end of the calibration, there is a pretty good Pearson correlation of 0.9 for a sample of 3,200 data points. That's the main justification in the literature for using tropomy as an emission proxy rather than a concentration, even though it's the measurement that it is doing. Now, in terms of results, based on the justification, the methodology, and the data validation process we explored, now we start processing the data for Rwanda, and then we did that for several settings. Here, first of all, it's let's say, an average and the minimum and the maximum and the standard deviation for the year 2022. So meaning from the beginning of the year, January 1st to December 31st. So for the average methane, what you will see here is that the average is much larger in the north rather than in the south and in the center. Here again, we are not going to provide any explanations why we have that. That requires collaboration with you colleagues to bring explainability to this data. But what we realize is that the minimum here, which is the second panel, meaning 1, 2, the second map on your right at the top, we realize that the minimum for all the pixels in terms of methane concentration, and here based on the justification emissions, is found in the south. The highest value in the minimum is found in the south. But for the maximum, we realize that the highest values are being found in the north. The north, we will see later in other slides, is where actually we're having a lot of concentrations. Again, this will need to be subject to interpretation based on the local knowledge of the land use and land cover seen. Now, again, one last point here is that we don't know yet what a normal range of concentration or emissions might look like. This is also one integration we ask ourselves just to see what can we consider as normal, because once we have that value of normality, we can start measuring deviations and anomalies. And from there, link it maybe to land management practices and see what can be done into changing that trend. But I think this is also another question we need to ask about what is normal, the normal range of methane emission in the country. The second setting we tried here is to look at the concentration of, for this one, it's only above croplands again. We just did it above croplands, nothing else. We just crop it to croplands and see how is the dynamic. Now, the second setting is the Rwanda methane concentration over beans fields. What we were trying to see is the dynamic of the concentration change of methane in ppbv, which is part per billion volume, and for the year 2022. And on the x-axis, you will see the short dry, the 4 main season, I think, if you can put it that way, for Rwanda: short dry season, long rainy season, and so on, for sowing, for growing and harvesting. And then we see also this sort of, let's say, footprint, because they're all the same actually for the areas that we looked at, even though there are small gaps in terms of intensity and concentration, but the morphology of the signature is similar. I think we need also to bring more explainability to this. We found similar things in Senegal, not the same shape, but some similarities between crops when we look at these this DNA, if I can put it that way, in terms of concentration. We also looked at maize and sorghum in Rwanda based on the agroecological zone that you see on the legend on your right. It's also similar, but the values in terms of concentrations are different. And we also see that the slope of those changes are different. So this also means that we need to also see if this is a, let's say, empirical knowledge we need to consider, or we can explain all of those slopes, why they are changing between the two crops, even though we can have an idea about it because they're not the same crops, but we still need to further investigate these values. Now, we start looking now, the third setting, the average emissions during the sowing season, which is the first panel. The one in the middle is during the growing season, and the one on your right is for the harvesting period and for the long rainy season over croplands. So what is constant here is that the highest concentration will be found based on this methodology in the north. And then again, what I put here in the bottom is while the reason for that are unknown to us, but further investigation will help us to bring explainability. But something is sure, the values are a bit different. But if you look at the geographical distribution of the concentration, here emissions for this season, they are the same in the they are the same in the north in terms of distribution. Now we have something a little bit different, which is for the short rainy season between September and November. You will see that the maximum values for the sowing and the harvesting period are the same in terms of geographical distribution. However, for the growing period in the middle, we see that in the south, we start having highest values of methane emissions. So we don't know what is going on there, but at least the main idea of this study is to start seeing changes. And now a second layer of analysis would be to start attaching these values to land management and land use, land cover changes on the ground. And also, land management, I already mentioned it. Now, in terms of now short and long dry season, we looked at also the average value for the year 2022. We didn't publish anything yet, of course, but we see that the northern part also is showing the same thing. Again, the maximum values will change, definitely. And the center of the country, if I can say, is remain usually in the middle range if you look at the legend. Now, this is my last slide. So the tropomy data allows us now to establish a sort of baseline of methane concentration. And here we can say also emissions above several land use and land cover in the country and through time. So the data has been already processed, luckily for the entire continent for every week, meaning also for Rwanda. And then we just aggregate the data for 2022, and we are going to look at the data in 2023 and to compare those two data and start seeing changes between the 2 years in terms of agricultural season, agroecological zones. And we hope also to start working with colleagues and see if we can have access to practices on the ground for explainability as well. Second, the time series analysis allows us to learn more and better the interrelationships between the concentration changes. Two aspects that we need to add is to further investigate their relationship with changes on the ground, but also with climate parameters like temperature and rainfall anomalies, where we can start looking at correlation and see if we have causality in there. Otherwise, we can just limit ourselves into looking at the geographical distribution and correlation among those parameters. Now we are expecting new methane emissions data sets with source allocation capabilities, meaning not only measuring the methane concentration, but that will be allocated to sources on the ground with a high resolution. We expect that by the end of 2024 with a project that has been done with the Google colleagues, but also with the Falcon X and some other colleagues there. And the data, the satellite is up there already on orbit, and then now they start receiving data and they go to the validation process. Hopefully we can have access to it by the end of the year. Access, yes, definitely to everyone. Now, when is we hope to have it by the end of the year, and the team is already gearing up to be ready for the acquisition and processing the data for Rwanda and for other CACCI countries. I will stop here for now. Hopefully I didn't exceed the time, Chair, and happy to hear from you about questions, suggestions that might support the work. Thank you so much.
Thank you very much, the very clear presentation. I think all of us are learning a lot, even though we have been following some of these presentations since you started. So I guess in the room there are questions or comments, contributions from the audience. Let's take like 10 minutes to collect a few and then engage. I mean, let's give 10 minutes to the room to engage with you on what you have submitted so far. We can take the first three, and then we allow us to respond, and then we take a second round. Over to you, sir.
Oh, thank you. Thank you, Racine, for the presentation. It's very nice, full of new findings and insights. So last week I was talking with someone called Dr. Peter. He's one of the initiators of Tropon. So I was asking her about how they use tropomy in climate change science while it is daily. So it means it is a satellite which can measure the methane at daily scale. In climate change.
Sorry, can we please have the microphone closer to him?
Yeah, sure. Oh, sorry. So I was saying I was talking with Dr. Pittenel. Maybe you know her. She's working at UCAR, University of Corporation for Atmospheric Research in USA. So he's one of the founders who launched the Tropomi satellite. So I was challenging her that how they use Tropomi in climate change science, because climate change is talk about the long-term variability. So when we talk about climate, it's about how the weather was changing across the time, long term. And Tropomi was launched in 2017 in October. And when you are using methane, I like that you present that methane has like a lifetime of 12 years. So, and normally I was asking her, how you know that just a specific day, like let's say like today, how you are going to know that this methane is specific for that day, why it is going to stay 12 years in atmosphere. So she said what I wish to hear from her about the backward trajectories. So, and in your presentation, I didn't hear about the weather dynamics, means the winds, the effects of wind. Normally, for me, I like, of course, I use at Rwanda Space Agency, of course, we use Tropomi and some of other satellites. For me, when I talk about climate change, according to WMO, World Meteorological Organization, the climate change is defined as at least 30 years. 30 years. It's not about 10 years, 5 years. It's about at least 30 years. So it means if you are using Tropomi, you are not dealing with climate change, according to the WMO, because Tropomi have been launched in 2017. So it's not about 30 years. So for me, I like to use like IRS. IRS stands for Atmospheric Infrared Radiation Sounder. It was launched in around maybe 2002. And according to your slide, the spatial maps, there is agreement about the higher concentration of methane between Tropomi and the IRS. But my results, I found that most of the higher concentration are located in both northern and western, not only northern. But in Rwanda, we have the wind we have, most of the wind we have are what we call in meteorology, southeasterly winds. So it means the most of the wind we have in most of the seasons are coming from the south and east. So it means the methane we have in south and east are transported towards the northern, where you found the higher concentration. So this is one of the reasons that we have higher concentration. But there is a need for more research about it. So I didn't, maybe for next time you should also think about the wind, the factor of the wind, because in Rwanda. But in the DBF, December, January, February, the wind changed. Normally we have the wind, during December, January, February, we have the northern wind coming from northern. But in general, it is southeastern wind. So my advice or recommendation is that you should also consider both Tropomi and IRS, atmospheric infrared radiation sounder, because from the IRS, you can get the data from 2003. So I get the results from 2003 and 2023 from last year. So you can just make, and also in terms of data analysis, I recommend that you can also do something called the spatial trend distribution. So it means you take, for instance, 2017, if you start from 2003 to 2004, you make subtraction to check to see how there is increase or decrease. I saw that you are CV, you are a mathematician, maybe you are better than me. So you can do this kind of analysis to compare the distribution, I mean, how it was increasing or decreasing, so that you can know if this kind of crops has resulted to this kind of increase or decrease of methane. Maybe just to conclude, I want to ask you about what do you think about using the modeling? I'm not talking about the statistical models, because the statistical models have some limitation. I'm talking about the dynamical models. We are going to collaborate with UCAR, as mentioned. We are going to use WorldChem. It is a model which can which can predict this kind of chemicals. So what do you think about the impact or using the modeling to improve our knowledge on this kind of impact of climate change on greenhouse gases? Thank you.
Thank you very much. Let's take another question or comment, and then we allow Racine to respond.
Yeah.
Yes, Eric, please.
Actually, it's very interesting to listen to Didier and Racine. I think this most of the interesting discussion, because they are all using the same methodology. They understand maybe more than I would understand. So I had a comment as Didier was mentioning how to understand, because as you say, it is 2023 data analysis of methane, and then you don't have a real concentration of methane on the as you mentioned in your result. But what is my question was about to understand what is the backward impact of analysis of the methane, since we have now the 2023. So for us, it will be more interesting to understand if using the methodology you're using or mixing what Didier was mentioning as well, is it possible to have a backward concentration to understand the trend of our methane? Does it increase? Does it decrease? Because now we see like we have the concentration of the top, and there's a lot of activity, there are also action that I use, mitigation action, adaptation action, that maybe could reduce the concentration or increase the concentration. Of course, you presented on the crops, different steps of crops yield, crop production, but having the backward data and to understand what is the trend from, for example, 2020. If we work in 2023 now, it's probably maybe it's a baseline. Like you consider that as a baseline, then you can go to 2023 and then say, okay, we can go to 2020 probably to have these 4 years, as you say that we have 12 years of methane in the atmosphere. And then don't go beyond the 15, 12 years, probably, but just take 5 years and see if the trend can be possible to measure and to estimate, say, okay, the concentration have moved. And then also, I understand that there should be also a wind impact on this concentration on the presentation. So is it possible to have this analyzed and then understand the impact of our activity, for example, in northern parts, and what was in 5 years back, and then today if it has increased or decreased, or if any change has happened? Thank you.
You don't hear it? Thank you. Racine, I guess you want. Yes, please. Additional question, then you can take the floor, Racine.
Can you hear me? Can you hear me, Racine?
Yes, I can hear you.
Okay. I also just wanted to build off of what Eric and Gail mentioned. My concern would be mostly on the validation process of this troponin data, because we're looking at these greenhouse gas concentrations. We would like to know what is Rwanda contributing as Rwanda, you know?
Mm-hmm.
For example, in aviation, we took a long time to really estimate emissions from the aviation sector because of, you know, international flights and so on. So we are interested in what is Rwanda contributing in terms of the greenhouse gas concentration, so that we know, you know, the total emission for this case methane. So I would like to understand better what your validation. How did you exactly do the validation? And is this data that we can actually refer to, because it's quite interesting, especially that it is, you know, on a spatial level. So that's the first question. I also wanted to know if you can quantify these concentrations of methane on an annual basis. Is it something that is possible? Is it something that you looked into when you were doing this analysis? Another small question is, can troponin also cover other greenhouse gases? Is this something that you are mentioning in the end for future data that we produce, the set that we produce at the end of 2024? I didn't really understand or hear well. So if you can talk about other greenhouse gases, it would also be helpful.
Mm-hmm.
Thank you. What you are saying?
Yes, thank you so much for the questions and suggestions. So for the first colleague who asked questions, I think there are very important contributions there. So thank you for sharing that you are using another source that goes all the way to 2003. And I will have a look at it. Now, the question would be, what would be the spatial resolution of that data set for 2003? It should not be a problem, even though if it's coarse, given like doing some more analysis to do some downscaling. But I think that will impact a lot the type of analysis we can do there. The second, so that is a contribution that I welcome, and I will have a look at it with the team. In terms of spatial trend distribution, so here we looked at the 2022. Now, if you want to compare and have that trend distribution, it means you have several years and several months where you look at, as you said, the troponin is fairly recent. Our goal was not to look at the trend from the last 30 years all the way to now and start looking at it, but at least can we have a baseline based on the recent methodologies that are available. Now, in terms of making sure that we can look at the trend, there are some preliminaries that needs to be done in terms of data fusion. If you have a data set that comes from another source with a different methodology and a different calibration, if it is ensured that the calibration and the relationship between that data set and the new one is done in a robust way, therefore it's possible. I wouldn't maybe bring in two data sets from two different distributions, from two sensors, if they are not validated, and then in terms of fusion, of course, and make an analysis based on that. Maybe we can segment it from 2003 all the way where the mission stopped, if it stopped, or looking at the newest data set and try to find that that correlation between the two, if it exists. I don't know yet because I don't have access to the data. I didn't have a look at it, but I will be very happy if you can share the link, and then if such a validation exists, of course, it would be something we should consider definitely. Now, in terms of impact of modeling, oh no, sorry, before that, for the circulation of the weather, the wind. Now, in Tropomy, of course, there is circulation. Wind will be there, and that will have an impact probably on how it is distributed. But today, to the best of my knowledge, I don't see a model that, or a satellite that will collect greenhouse gases and will incorporate wind circulation within the satellite. You will have to bring in another model or a climate model to be able to start looking at that distribution. Now, if you have the wind, is the wind strong enough also to move those methane, and to what extent it will do that? I think we can go very deep in the nitty-gritty of how that wind is going to impact that methane or any greenhouse gas in terms of molecule in the atmosphere. Because the vibration, for those greenhouse gas to have an impact, they need to vibrate. So that vibration level, how does it interact with the wind circulation? For example, the reason why CO2 and, for example, methane CH4 are able to absorb and re-emit infrared is because they vibrate, they have dipoles. And we know that that also is very sensitive to, I mean, to what extent the wind is going to impact that vibration. Because even if you circulate the gas and it doesn't vibrate, you know, it won't be a greenhouse gas actually, or the impact will be reduced. So I'm just trying to mitigate a little bit here the discussion, because indeed it's true that circulation will have an impact, but to what extent? And how does it impact our measurement of the concentration, and how can we bring it all the way to the emission level? Now, the level of discussion here, I've been trying to share the result is, that's fine if the circulation is not incorporated in the measurement, but at least can we have a concentration at least? If we have that now, based on the second methodology, there are some models, and that helps me to switch to the last question, which is the GraphCast, or which is a model that is basically modeling some atmospheric parameters, those who are close to the Earth and some that are atmospheric. And it has been developed by Google as well. It's a graph neural networks, and it used the ERA5 datasets. I think Marceau is aware of that. And then the model now is being used as a test at the Climate Center in Europe, the ECF, to compare it with the climate models. And the correspondence between the data is pretty interesting. Now, the idea here would be, how can we use the GraphCast into the model? And bearing in mind, we still need to answer the question, how does it impact the greenhouse gas effect? So we're not there yet. We're still making sure that the circulation climate model of atmospheric parameters is calibrated and well functioning, and then that would be something we will consider. But we are not there yet. What we are trying to do as first is, can we make sure we have at least a baselining on that? But absolutely very open to discuss further if you would like to follow up on this. Questions are being raised in the community and even within the team, I'm sure, at the Rwanda Space Agency as well. Maybe comparing notes also can be beneficial for CACCI and for other projects within the country. Now I have a question for Eric, comparing with other years. This is something we will definitely do, Eric. We didn't do this. The data is available, processed. It's just not, we didn't do the analysis here. And this is something we will definitely do. And that helps also to answer the question of the first colleague about like having the special trend distribution. Actually, even better, we can do a clustering, start looking at the trend by cluster, which is an unsupervised classification method. I think colleagues there are aware of it. And then now making sure that we can look at the data by cluster and how that cluster will move the cluster center. So Eric, we will do that definitely with the data. Now, what is Rwanda contributing as a country and how the data has been validated into that? So here, the validation of what, well, first of all, to know what Rwanda is contributing as Rwanda, we need to have the emissions levels from the ground. The validation that I hear from that type of discussion is making sure we have access to the emission factors and also what are the human activities that are emitting. Now, us here, what we did is mainly being at the top from the ground and looking at the concentrations. Now, how do we link it to activities on the ground? That depends on the type of data we get from the ground. And we don't have that yet from our side. The validation that has been done here is not us as academia 2063 who did it. It's a validation of what the instrument is providing from the satellite and what the stations on the ground are providing. And if there is a gap, there is a bias corruption between the two to make sure that whatever the satellite is providing is closer to a picture from the ground. That's the validation we looked at to make sure that the data can be used at least to have an assessment. Now, can it be used to assess like what are the emission factors and what are the human activities on the ground that leads to this? Also measuring the impact of that circulation? No, we didn't do it yet. But I think there is a project we are trying to work on, which allows actually to start measuring emission factors. If you look at, for example, the IPCC methodologies, the emission factors are pretty by default for African countries because of that lack of data. And we are trying to have a position paper around that. So we'll be very happy to collaborate on this if we can have access to the Rwanda data and start initiating the process. But for now, our methodology is just on the measurements, and that's where we stop that. One last point that I noted is the data we expect by the end of the year, right? So it's, I'm sure you've seen that there's a satellite called MethaneSat that has been launched actually early in March. And the characteristic of that satellite is it is going to measure the emissions, but at the same time also it will attribute the sources of those emissions. So there is no direct, there is direct measurement, but the attribution to sources depends usually on the type of spatial resolution that you have to start tracking really the density of that emissions and start attributing it to sources. You will have algorithms every time in those measurements. You will have models in those. A model cannot be 100% perfect. It's a model. It's trying to replicate the reality with a certain level of error. But I think at the end of the day, when it comes to climate, I would rather have a model that gives me like an estimate, at least to not to be blind to the situation, and using it if there is enough clarity in the methodology and robustness and accuracy assessment. But the data is expected by the end of this year, 2024. There are big hopes and expectations actually in the community to start having that data and its global coverage. And I think one exercise could be getting that data, attributing to sources and compare it with data from the ground. The only issue we have in Africa is that we don't have that much stations to measure those greenhouse gases. I understood that some stations are available in Rwanda. And I think that would be nice if that data can be compared with the stations and not stop at comparing it, but calibrating actually the data coming from the satellites for the own use of the country. I know a lot of countries in Africa that don't have those stations. I think it's a blessing to have it and to move this needle further. That's what I had to say. Hopefully I answered the questions. I'm still open for collaboration. If there are also follow-ups and questions and recommendations, I'm also open. Over to you, Chair.
Thank you, Racine. I hope you have answered all the questions to the satisfaction of those who asked them. If not, we will still have opportunity to network, and colleagues can also reach out to you. We would like now to invite the second presenter. The next presenter will Hadim. I hope Hadim is online. Mansour, oh yes, Mansour is presenting on the spatial distribution of climate risk using remote sensing data. Yes, we are privileged to have you in your room. The engagement, yes, please go ahead. You have 15 to 20 minutes to present. Then we'll have an opportunity to engage with the audience following your presentation. Thank you.
Dr. Abisa, thank you to all of you to welcoming for this CACCI Rwanda seminar. I am Mansour Jah. I work at Adaptation 63 as an associate research scientist, and I will be presenting the work that my team, including Dr. Racine, and for this work, which is about the spatial distribution of climate risk using data. We started the project focusing on West Africa as for region, and then as we go, we needed to go into at the more level, and then that's why we started to see what happens in some countries, which was Senegal and Nigeria, and represents what the results and the configuration that we had for Senegal. We'll be talking about stop talking on water bodies, rainfall for properties, and also we will talk about exposure and vulnerability to climate risk. So that has global impact, and we all know that the government incentives exist, but this requires support to comprehensive measures and climate mitigation strategies. And as a country, Senegal, because of its unique geography, is potentially susceptible to climate change impacts, but also the fact that most of the agriculture is ranch agriculture amplifies this vulnerability. And then it's also the population, right? The agriculture is from the backbone of the Senegalese economy. 70% of the population is active on the agricultural sector. Value variability manifesting as droughts, floods, events poses direct threat to provenance and by extension to the national food systems. This is why the necessity of understanding climate impacts on care agricultural variability is paramount for business. So this is the land use land cover in Senegal, which is shown in the map, and we can see that the land in Senegal is mostly predominated by shrublands, which covers 33%, which is followed by the herbaceous vegetation, and the forest, which covers 21%, and the crop plants, which covers 20%.
Mansour, are you presenting for Senegal or Rwanda?
Senegal. So we performed spectrum exercise for Senegal by using satellite remote sensing data and for surface water bodies, rainfall, and soil characteristics. For the surface water bodies, the data was for 38 years from 1984 to 2021. And two metrics was considered: the change and the transitions. For the rainfall, an anomaly metric was used to measure divergences between the year 2021 and average of the last 20 years. And for the soil characteristics, two filters was considered, which was the soil pH and the soil organic carbon, which was found at between 5 and 15 centimeters. So for the water body change, the water occurrence change data was collected from the global surface water datasets, which is from the Geological Center, the European Union. The changes and transition are intended to show different facets of the spatial and temporal distribution of surface water over the last 38 years. The changes provides information on water occurrence on different locations. It shows if water occurrence has increased, decreased, or remained the same during these 38 years. Change in water occurrence intensity between two epochs. The first epoch is from March 1994 to December 31, and the second epoch was from January 2000 to December 2001. The occurrence between epochs was computed from homologous pair of months, and difference between all homologous pair of months were then averaged to create the surface water occurrence change intensity. This map shows the water body change in Senegal, and as we can see, the red part was where there is a loss of occurrence, and the green part is where we have increase of occurrence, and the dark ones are where there is no change. So let's focus on a special area. Here is in the south of Senegal, in the Casamance River, and we can see, for instance, in the river, there is no big changes for the river, and we can see like there are increases like around the river that are coming, and we can see the rivers in the pink lake, where in the pink lake there is no chance, but in the environment around, we first see a loss, and then we see also some increases. So let's talk about the transitions. The transition that provides information on the change in surface water seasonality between the first and last year of observations. That is the changes between the three classes of normal water, seasonal water, and permanent water, where the two last classes are divided into subclasses. It allows to show the changes in the first and last year that the data was observed, but not in the immediate year. The permanent and seasonal are composed of permanent water. It is the unchanged water, the unchanged permanent, new permanent, lost permanent, permanent to seasonal. The seasonal water is the unchanged seasonal, new seasonal, lost seasonal, seasonal to permanent, ephemeral permanent water. The land replaced by permanent water that subsequently disappears, and ephemeral seasonal water. The land replaced by seasonal water that subsequently disappears. Transition in Senegal, and the blue one are where the water is permanent. And we can see for some parts in Senegal, here is the Casamance River. And the Casamance River also, we can see that the river itself is staying permanent. And new permanent surfaces are appearing close to the river. And in contrast with the Pink Lake, of course, the Pink Lake is staying permanent, but you can see that there is part that is staying permanent, but you can see also some parts that we are losing. That means there are some who are becoming seasonal and some parts that we completely lose. Now about the rainfall, so we calculated the anomaly of the rainfall in Senegal. So by looking at the at how the current year, which was the 2021, deviates from the last 20 years climatology. We observed that most of Senegal regions, such as Tambacounda, Matam, Kolda, Saint-Louis, Dakar, experience rainfall increase between 0 to 20 millimeters. We observed that also the rainfall decreases in large part of Senegal. This is observed in Saint-Louis, Louga, Kédougou, and south parts such as Sédhiou. Rainfall substantially also decreases in part of the south, notably in Ziguinchor. Now, for the soil characteristics, as I said, we looked at the soil pH and the soil organic carbon, which was found between 5 and 15%. So, for the soil pH, depending on the value of the pH, that made some kind of crops suitable to grow. We found that majority of cropland in Senegal are moderately acid or neutral, and said condition provide minerals and nutrition solubility and therefore their ability to the plants. This is favorable for some major crops included in Senegal, such as rice and groundnuts. We found also that 16% of cropland soil in Senegal are strongly alkaline. That means the pH is between 6.5 and 8, which is favorable for sorghum and millet growth, but minorly favorable for some other crops. And 70% of cropland soil in Senegal are either strongly acid or strongly alkaline. And sedentary soil pH causes aluminum toxicity and nutrient unavailability, which also might hurt the crop growth. For the soil organic carbon that we found in cropland also, we see that the amount of organic carbon in the north region is small and less than 10 grams per kilogram. This is the rivers on the south parts where we found more carbon in the soil. Let's talk now about exposure and vulnerability. We took the drought index as exposure, and we talk especially about agricultural droughts. So we use an index which uses two parameters. The first is the NDVI, which is the normalized difference vegetation index, and the surface and the land surface temperature. So this methodology was developed and by some other scientists, and we have references in the final documents. You can see about the methodology, but what they did is they computed the RNDVI, which is the ratio between the NDVI of the year compared to the NDVI of the long term, which is in the last 20 years. They also did the same for the LST, which they call the RST, and then the final draw index is computed by taking the RNDVI over the RST square. So, and in the Senegal, you can see the special distribution of the drought index. And we found that most part of the country are exposed to agricultural drought hazards. The fact that agriculture, we found that in the east part of Senegal, is more exposed to agricultural drought hazards. Matam, Tambacounda, and Kédougou are more exposed. Drought is less severe in the center of Senegal, in Kaolack and Kaffrine. The north and south of Senegal is moderately affected or drought-free. About the population density, we used the adjusted breeding population density of the world data sets, which and we use the adjusted version, which has 30 arcs special resolution, which is about 1 kilometer at the equator. And here we have the special distribution of the special distribution of the population density in Senegal, and you can see how the population is in some urban areas such as Dakar and Thiès. In order to measure the exposure and vulnerability of communities against climate risk, we combine both drought index and the population density. The combination uses thresholds to divide the data into two categories: high and low. The threshold for both data set was defined in a data-driven manner. So here is the special distribution of the exposure and vulnerability in Senegal. So we found highly exposed to drought areas, especially in the east of Senegal, in regions like Matam, Tambacounda, and Kédougou. However, the population density is low in this area. Thus, the drought is severe in the east, but few population affected. The same is observed in some part of Kaolack. Most people are affected by drought are found in the western center of Senegal, in some part of Louga, Thiès, Diourbel, Kaolack, Kaffrine, and Fatick. Vulnerability is high in these parts, as they are very dense and strongly affected by drought. The north, in Saint-Louis, and part of Louga, and the south in Ziguinchor are more resilient to drought. Low drought and drought-free areas are predominant in these parts. To conclude, climate change is having significant impacts on the climate variables in Senegal, with serious consequences for human well-being, the environment, and economic development. Precipitation patterns in Senegal are also changing, with some areas experiencing increased rainfall, while others are becoming more arid. This has significant implications for agriculture and security, as well as for the availability of water resources. Extreme weather events, such as droughts, are becoming more frequent in Senegal, with severe consequences for communities and fractures in infrastructure and economies. It is essential to implement measures to adapt these changes and to reduce greenhouse gas emissions to mitigate their impacts in the long term. This is what I have to present. Thank you. I'm waiting if you have some questions or substitution.
Thank you very much, Ansu. Yes, for sharing the lessons learned from the Senegal component of the project. I think the town has some
Yeah.
comments or questions.
Yeah, I have the idea. Is Hadim online? Hadim? No. Yes, I think, I know we have been working for Rwanda. I don't know when the progress is, the Manso. If you know anything about the progress, what has been done for Rwanda, you can bring details about it, the status. I know we had a challenge of the resolution because of the size of the country. And because of the satellite data, we had an issue. And you have been discussing about the resolution issue and all these things. And maybe because of that. With that, I think we have to the solution for Rwanda. So for colleagues, just you can comment on the methodologies and whether how that, for example, the calculation of the development days.
Sorry, get out. Can you have the mic closer to you?
Any progress you have done for Rwanda, you can briefly tell us about the progress. That is my question. Did you hear?
Otherwise, the audience can just comment on the methodology and the data.
Can I have a question?
Yes, of course.
Yes, sir.
Maybe for
Manso.
Yeah. So, from the perspective of Rwanda, is it possible to have to use the same methodology, but just say you have an issue with the size of our country, the resolution? Is there any way to maybe space agency colleagues will support on this? To have the same analysis, because I think we did the same something like this at the beginning that you present to the Ministry of Environment on the forest cover in Rwanda.
Yes,
but not as deep as what our colleague presented. So, is there any possibility of doing the same on Rwanda with the other methodologies to make it work?
Thank you, Eric. I think there's a follow-up question at the back there. Hadim, I hope you can still hear us.
Yeah, I now I'm hearing you. Yeah, I think I got the first question. Yeah.
Okay, we are having a new question, and then you can react from there.
Yeah, thank you so much for the presentation. I'm going to make a comment on the methodology. If this is going to be applied across different countries, because the mission started with Senegal, Nigeria, and the targeting to some countries, but the result presented is for Senegal. So my comment is on the soil properties. Soil properties, we are just focused on pH and the organic carbon. But the question is on the sampling there. There, we considered 5 to 15 samples there. There, any special on that. If you go in other countries, for example, in Rwanda, you may find another different approach where we consider maybe 0 to 20, even you can go up to 30 centimeters of survey for something. So, if you are very problem to do this one in different country, that would be a kind of harmonizing
Yeah, if you are considering 0, that means you are not digging. Yeah. No, that was just on the light note. I'm saying if you are considering 0, you are not digging. you are remain on the surface?
No, when we are collecting sample, we use the air astrometers for sampling, like the over. We start from the toxin, so the surface, go down to
Okay, very good. So there's another question, and then we can allow the presenter and Paddy to react, please.
Yes, thank you very much. Allow me to present. I'm Greg Pepe from S3 Rwanda. I'm agriculture industry solution manager. Yes, just comment on the methodology that we are usually talking about extreme weather, and just mentioned about drought. Extreme weather is not about also not only about drought. Some projections show that in the future we are not in Rwanda, especially in Rwanda, we are not dealing only with the drought. There will be also extreme rainfall. So to suggest to consider also there is model even online that show that in some part of the country there will be extreme rainfall, and that would be also a harm for agriculture in general. So that's something that we should consider doing here. And talking about what is existing about climate risk mapping, there is a lot of study that have been done. So we should refer to that your methodology and refer to them. We know that we've been doing something with several partners, RAB and Minister of Environment about climate mapping. So please consider also extreme rainfall when you're talking about extreme weather as well.
Thank you very much. DJ, let's try and clarify these few. We can. Mansour, Hadim, who starts first?
Yeah, I think I can start, and Mansour can complement. I think, yeah. I think for the first question, if I hear well, it's more about how we can try to duplicate the work here we did in Senegal, Rwanda. Yeah, so basically all the thing we did, for example, this one we did it for the all West Africa, and Rwanda is always the size of the country, I think, and always also some clouds related issue, but we can try to do something there. But I think we will need also data from your sites. Meaning that, for example, if you have a better data related to the land use, land cover in your sites, also that can really help, because we can try something, but usually it's really the small size, and the size of the pixel we are getting here are too huge to cover Rwanda. So we need to find another source of data. So we are open for that, because the methodology is there, the computation is there. So if you are ready to help us on that side, I think I was talking more about the RSA. So if we can work on that way, we are open. So to provide this analysis, because the objective is to produce this analysis for all the CACCI countries. So also, I think I didn't get well the second question. Maybe Mansour, you can remind me that, and after you can take it and I can complement. And about I think the question on, no, it's just the suggestion of taking into account the extreme rainfall. I think it's a good suggestion. We are going to take that into account. And as I can say, for example, if we use, for example, the rainfall anomalies, if also there is extreme rainfall, we will capture that in the analysis, because extreme rainfalls also can be very harmful. And we try also to link those, for example, those anomalies, temperatures with the prediction, for example, we are doing on the agua sites, where we try, for example, to link the current.
Are you talking to, sorry, Kalim?
Hello? Hello?
The connection is a little bit weak.
Oh.
We cannot hear you.
I'm hearing
Can you
you.
please?
Pardon? Okay,
maybe have a connection.
Yeah, maybe Mansour can take over while you are. Can you hear us? Mansour?
Okay, Hadim. Okay, I was continuing what Hadim was explaining. So in this part, he was saying like, okay, it's a good suggestion that we should have the other extreme events. And I think also what he was explaining was also the rainfall, maybe if extreme events maybe concentrated in what we talk about, the anomaly rainfall, the most that we have, which is how the rainfall in the year has deviated from the last 20 years, and we can see if there is extreme increase of the rainfall, or if there is extreme decrease of the rainfall compared to a climate condition which might be the last 20 years or the last 30 years.
Okay.
Okay.
You can carry on the other points that were raised.
Yes, the other question which about the soil characteristics. Thank you for this suggestion. I think, as you said, we might go beyond only soil pH and the soil organic carbon. And I think we started this work. And now we have the data for soil moisture and soil and catchment exchange. And also, it's as you said, between 5 and 15 centimeter, we are not, of course, capturing all the processes, and maybe the idea would be to have at least 30 centimeters, but it will depend on the country and what is available. And if in the country we have as a source, for instance, in Rwanda, if you have some source that goes to at least 30 centimeters, I think they are welcome, and you can maybe reference that or the data results.
Thank you. Maybe one, the soil depths sampling. I'm not an expert on that area, but I can see from our discussions and all these things, this is based on the satellite data. Based on the satellite data, they map it. It's not based on sample taken from different areas. So possibly because the source of this satellite data was the same source, and then we can make, the same soil depths. Maybe whether that makes sense or not is something, because maybe the same depths may not apply for Nigeria and for Rwanda and maybe for other countries, but it's possible to get almost similar comparable data from the same sources. Yeah, that's what I understand.
Khadim, are you there?
Yeah, are you hearing us?
Yes, we can hear you. Is there anything you wanted to add?
Yeah, I think that was just the thing. Here we try just to see all the parameters we have on the ground, because we do also another work to link, for example, those characteristics of rainfalls, of soils, and try also to enhance, for example, the model we are using to predict, for example, the crop. For example, when there is heavy rainfalls, usually we revise, for example, the prediction we are doing. We know that will be impact the production. Also the soils, the pH level. So we are trying now to just try how we can incorporate all those aspects also in the productions and the forecasts, the model we are using to predict, for example, crop for all African countries. So that's the work we try to do. Try first to see, for example, what is the extent of those climate variables in the countries, and also the next step also is to see, for example, how they are going to affect the crop production, for example. And also in the work, you can see that we try to see the drought, the population density. And for example, one thing, for example, is, for example, in the northern Senegal, we see that, for example, we have high drought and low population density, for example. For that one, link that to category 2, but maybe it can be category 1 because, for example, it's maybe the draw that forces, for example, the population to go elsewhere. So this also can be a high priority. But now when we do the clustering, we just rank them second, but maybe it's because of the draw that the population is going elsewhere. So we try to see also the explanation, but these will need, for example, data on the ground, as we just say, trying also to link the work we are doing on the satellite side with the socioeconomic data to provide, for example, explanation from data on the ground. So I think the satellite data, as I think Rasim just said before, will give us, for example, a broader picture, but we will always need collaboration with the ground data, socioeconomic data, just to link the explanation, the why this is happening. So basically, that's what I wanted to say. And also, I think we will be happy also to do the same work for Rwanda, and we are open to collaborate, to share data and see if you can help on the data side and also on those dynamics going on the ground. Yeah, thank you very much.
Thank you, Hadim. I know Didier has a question or comment.
Yes, thanks for the presentation. It's not my area of expertise, the agriculture area, but I'm interested to learn more like this kind of soil. I know at Rwanda Space Agency, some people, they use this kind of soil moisture depths different, so the data are available. And thank for NASA's and the ESA's, those big agencies, they provide this kind of data for free. So it's not about, I know, as Geto said, we have issue of spatial resolution and temporal resolution, but it's not all satellite data that have that kind of limitation. So this just is some of the collection. Rwanda, of course, geographically is small, but there are some data with very high spatial resolution. For instance, TAMSAT has provided data at least, every 3 kilometers spatial resolution. So you can see it is very, very high, every 3 kilometers. So you get the data across all Africa. 3 kilometers, so it's a very high spatial resolution. So you can use even ERA 5, Racine mentioned before. You can use, for instance, what in Rwanda they have at Metro Rwanda. There is also another product they have. So there are many satellite data, even GPM, global precipitation monitoring. It is very, very high resolution, spatial resolution. So we have many kinds of data, whereas it's not about issue. The problem is where you fetch, where you get the data. Maybe people that don't have the source of those big high spatial resolution. So it's not about there is a limitation of this kind of thing. So maybe there is a comment of NDVI. You talked about NDVI. Yes. Normally in things of drought research, they have published and so on. NDVI is not often used in drought research. We normally use SPPR, maybe you know it, Standardized Precipitation Evapotranspiration Index. This is one of the index they use in drought, research. But when we talk about NDVI, it's about the crops, the agriculture areas, and the vegetation. And maybe I can recommend you also the EVI, Enhanced Vegetation Index. It's also, some people, they prefer some areas, they have shown that EVI is better than NDVI, comparing the land, how it is, the soil type. So you can also think about the Enhanced Vegetation Index. Maybe just to finish, someone was talking about the cloud issues in Rwanda. It's normally the tropical area. The tropical area, we have this kind of very convective systems, and we have too much cloud. This is another, even for tropomy. Tropomy people, they have just used tropomy, and especially in tropical region, it cannot detect the area in tropical region for methane, especially for methane, because of the cloud coverage. So I think also you may think about this kind of analysis in terms when you are going to use this kind of satellite. You should ask yourself if this satellite is going to capture, especially in rainfall season where we have too much cloud.
in Rwanda, March, April, May, and September, October, November. Because some satellite can penetrate in cloud, others they cannot. So we think about this kind of thing. So my last question. So yes, Eric mentioned about that. I was expecting that we are going to hear about Rwanda. So, but yes, of course, we are only one the continent. The only thing I know in Senegal is about Harmattan, the Van Harmattan, the Harmattan winds. These are the only things I know that they are things. So, depending on the methodology you are going to use to Senegal. So I think you can also work with the scientists in Rwanda who are expert in this kind of soil things, soil type and agriculture. Because I think the soil type are not the coastal areas in Senegal. I think the soil type cannot be compared to tropical area. I think these are not good in that expertise, but I think you can also collaborate. And someone he just finished that saying that we may just combine the satellite data and the ground. This is what we do in Rwanda Space Agency. Because the satellite has some limitation. The ground data has some limitation in terms of coverage. So when you combine, you found a very good results. Thank you.
Thank you very much, Didier. I think Mr. Gatete also.
Yeah, it's he just responded. We couldn't already penalize because of the size of the country. Now the data are there, and he's well placed to indicate where is the data, because we know that we have a lot of models that have huge pixels that cannot work on Rwanda. But I think we solved that issue now with the Rwanda Space.
Okay, thank you very much. But just a disclaimer from Kadim to Mansu, what they said about the size of Rwanda was not an indictment on Rwanda. They were saying that technically they were not able.
This is not an issue that we only face at academia. I might be wrong, because that's not my area. Because there are some universities from Germany, they came here and they asked the same question. They were trying to develop a model for Rwanda.
They worked with the They want to work with the
with GIZ. Yeah, with GIZ. And they were here, and this is the same room. So we discussed about this. They are struggling, and it's because for Rwanda to develop because of the resolution. That's what they said. But it's also, as Jill said, it may be because they are using the same data, the same course, just like us. Yeah, probably. So that's why we
just seminar like this one.
Yeah.
We'll hear from Didier, from others who have experienced something different, and see how we can leverage. Are there additional questions? One or two, and then we'll break for tea. And come back.
I think we can break.
Yes, we can break. When we come back, those who have not been able to introduce themselves because they arrived late can quickly see who they are, which institution they are representing.
So when we come back, then we move from scientists, engineers to the economists. And we hear more about social issues of climate. Climate is everything. Affect health, economy, science, and everything.
So see you all in 10 minutes so that we can try and catch up on the time.
Okay.
On household vulnerability to climate change at national and district level using 2021 NIS survey. At this time, I think we'll be focusing on Rwanda. We make sure that we don't miss that again. So let me invite the first presenter. Please take between 15 to 20 minutes to walk us through your presentation on the economic-wide impacts of climate change and adaptation pathways. Yes, you are an agro-development we are also happy to report that he's an agro-development member, which is one of our expert network that we pride ourselves in leading. So, Henry, over to you.
Thank you, Augustine. Good morning, everyone. It's good to be back in Kigali, a beautiful city. I was here last year and I enjoyed my stay. I came in last night and I'm enjoying here again. Let me thank academia for giving me this opportunity. I'll be making a presentation on the economy-wide impacts of climate change and adaptation pathways in Rwanda. I want to emphasize Rwanda because I didn't see it there in the program. Okay, so please move on. Victoria contributed to this work, so by way of acknowledgement, you can see her name there. This, sorry. I have it here and I'm saying move on. Okay. Well, we all know about Rwanda. I just mentioned it's a beautiful country. The country has very beautiful topography, right from here in Kigali, and extending to east, west of the country, you have hilly grounds. And that's a major source of huge revenue to the country by way of tourist income. But then it could also be a source of climate crisis-induced trouble for the agricultural sector of the country. In fact, the World Bank notes that the small plot cultivation actually occurs on hilly ground and mountainous area across the country. And then with increased precipitation, as mentioned by one of our colleagues earlier on, or rainfall to be specific, we see that there is increased runoff and landslides, which has been experienced across the countries in farming areas. And that poses a lot of problem of vulnerability for the agricultural sector of the economy. We also know that looking at the Rwanda economy, there is this strong linkage or linkages between the agri sector and the rest of the economy. So it means the climate problem experienced in the agri sector can easily be transmitted to the rest of the economy. So in this analysis that we did here, the agricultural sector provides the main impact pathway to the rest of the economy. So we are using that to do it, and then it's based on an evidence-based study of economy-wide nature that tries to track the intersectoral linkages that is observed in the economy. Now, given the nature of the problem under investigation, it's also important to mention here that Rwanda has a robust national policy response agenda to the climate crisis or the climate change problem. For example, the country has submitted its outdated NDC, and then the commitments to fighting the climate problem is also guided by the Green Growth and Climate Strategy document. We also have the National Transformation Strategy Transformation document, but in spite of all this, Rwanda's diverse ecosystems still makes it highly vulnerable to extreme weather events. Now, with that background, the question now is, in quantitative terms, how damaging is climate change to the Rwanda economy in general and then to the agri sector in particular? And then if we have an idea of that, how aggressive will the country be in implementing its adaptation measures to combat climate change? Then we're also interested in knowing which household groups we suffer the most or the most vulnerable to climate shocks. So there are many climate household groups in this study, about 10 of them. We'll look at them very soon. And then if we identify the household group, then we'll say, okay, they are deserving of the highest priority in the implementation of the country's adaptation interventions. Then finally, we want to ask the question, what are the investment requirements needed to compensate for the economic damage that's attributable to climate change in Rwanda? So these are all adaptation questions that the government may be interested in addressing because of time. Methodological approach, we utilize economic simulation models for the analysis, which is basically an S&T analysis that projects into the future. The specific tools that we use comprises the computable general equilibrium models, as well as a positive mathematical modeling programming model. So these are a combination of these tools that we use. Now, these two models interact to capture issues related to growth, employment, and income generation, as well as household income distribution and household consumption expenditure. So these are in terms of output, what we will be focusing on. We apply this model to the Rwanda economy using the most relevant and most recent macro and micro data. Now, in terms of implementation steps, is usually a stepwise approach. We do a simulation scenario that are built on an exhaustive literature review of the country. So that's collected from published works to have an idea of the impact of climate change, as well as adaptation options on agri productivity over many years. Actually, to be specific here, we looked at 2021 to 2000 to 2021, so about 22 years. So that's what we did, so that we can have a long-term view of the climate issue in Rwanda here. Now, the second step is to create an economic account for agriculture. For Rwanda, this was particularly very difficult for us because of data issues. But then we were able to overcome there with the help of Victoria. And that is usually an input, a key input into the PMP model. Now, the PMP itself is useful in calibrating models of agricultural production and resource use using nonlinear yield or cost functions. Okay. So, again, let me just be faster. I'll skip some of these things, the details are there. So, but let me mention that the steps I just talked about, and then from PMP and all of that, we use them to assess all those key outputs that I said which we expect as results in this study: economic growth, employment, income changes, and all of that. Same procedure is applied to the adaptation aspect of the analysis. So we do that for both. Am I doing it wrong or something? Well, let's quickly look at some of the assumptions, the major assumptions of the CGE model that we used, where it's adapted to climate change issue by adopting a long-term closure rule, knowing very well that climate change is of long-term nature, as can be contrasted with climate variability. So we embrace the long-term closure. The labor, agricultural land, and other capital are fully mobile between economic activities. Again, we know that in the long term, you can actually adjust. So all these things, you can move from one sector to the other. And that represents a long-term situation where the economy has to adjust. Public expenditure and fiscal balance are fixed related to GDP. So it's a fixed share of GDP that we assume here. Investment is kept fixed related to GDP also, so not in absolute terms, but as a share of GDP. And the model is investment driven, meaning that investment determines total savings. So we simply allow savings in the system to respond to total investment, whether it's private, government, and foreign savings, all of that will respond to the level of savings within the system. Then sources of data. For every CG model, it is the social accounting matrix, SAM, that you use. So we use the 2021 SAM for Rwanda. This came from IFPRI, International Food Policy Research Institute. So it's the most recent official SAM available for the country. It has 41 industries, 41 commodities, 5 production factors, including agricultural land, 3 categories of labor, low, medium, and high-skilled labor. Then we have 10 representative household groups, ranging from low income to the highest income, and then rural and urban. So we divided based on income into quintiles, and then we have higher urban and rural, that makes 10. Now, Tondo 2021 provides more detail on the social accounting matrix that we used. Now, modeling the macroeconomic impact of climate change. In implementing the macro model, we adopt a stochastic approach to a static CG model. So, and we use a stochastic approach because we know that climate change is stochastic in nature rather than being deterministic. So there is this aspect of unpredictability regarding climate change. So, and this is one area where the study is an improvement on other studies that are related, where people use deterministic shocks as against the stochastic approach, and thereby ignoring the uncertainties associated with climate change and how that affects it. Now, the climate change shock is translated into variations in productivity of agricultural land. Consequently, it's propagated in the economy through the upstream and downstream linkages of agri with the rest of the economy. So it's majorly through yield or productivity of agricultural land captured climate change. Now, the simulation scenarios, we have 3 basic ones: the baseline or business as usual scenario, then the climate change scenario, and then finally we looked at the climate change and adaptation strategy scenario. The key outputs to expect or effects, will be on agricultural sector, non-agri sector, tracking the linkages there. Then effect on the macroeconomy, GDP, government income, employment and factor rewards, household income and household consumption. And then most importantly, the contribution of climate change adaptation strategies, where the policy dimension can be brought into the picture. So we look at the first result, which is the effects on agricultural sector. We see the business as usual on the left-hand side. For some of us here who may not be familiar with the computable general equilibrium model, the business as usual is the do-nothing scenario, where you assume that there was no intervention, okay? Or if you look at it between climate change and otherwise, we say, okay, assuming there was no climate change. So that would also be a business as usual scenario. So here, if there was none, this is what we will see based on the data, okay? But bringing in the climate change impact, we see that in terms of mean changes in agreed value added, setting crops based on the list of crops we have in the social accounting matrix will be worst impacted in the economy. And we highlighted some of them and also color-coded them. So we see yellow there, then it's high in our opinion. We see maize, other cereals, vegetables, coffee, tea, and cocoa will be particularly adversely impacted by climate change over the long run horizon. So that's what the result will be. We will see that there will be a huge productivity decline over the long run. Please let me just preempt you. Don't ask me how long is the long run. As economists, there's a way we think. If you ask me, I can just give you the answer right now. When Keynes told us many years ago, centuries, it's one of the fathers of economy, that in the long run, we are all dead. So we don't really have a specific time that is long run, but it's period long enough for everything to adjust. That's usually the acceptable definition. No dichotomy as in 10 years, 20, 30.
Excuse me.
All of that. Yeah.
Are these results for Rwanda or Nigeria?
That's what my question.
Oh my God, that was an oversight. So I'm a Nigerian and I'm so sorry. I guess it's Rwanda. So it's for Rwanda. It's results for Rwanda, not Nigeria.
You have Coco there. You have Coco there.
Based on the classification. It's so it's there in the social accounting matrix. Okay. That was what we used. So it could actually be referring to a family of crops. So effects on non-agricultural sector. So now we see to the left-hand side, those are negative impact, and then right-hand side, those that climate change really won't affect the sectors that are non-agriculture. So the most negatively affected sectors now are the ones of interest. We see public administration, construction, health and social work. So these are the ones that will be most affected, the ones at the bottom here. And one may want to ask, or maybe out of sheer curiosity, why these sectors? I would just say they are the ones with the least linkage to the agri sector. And then apart from that, if you look at public administration, for instance, climate change, later on you will find out that the macroeconomy will also shrink, the GDP over the long run. So that will also mean falling revenue for the government. So when there are budgetary constraints, we expect public administration to suffer also. So government will have less money for that. But then look upward, mining, other manufacturing, chemicals and petroleum, even information and communication, all of them will we expect them to post some positive outcome in spite of climate change. And they are the ones with little or no link to the agri sector. So they will continue to do well based on this model results. Now, these are just key macroeconomic indicators that we placed here, and then we will later break some of them down. We see that GDP is expected to decline by 4.8 percentage points. Did I say percentage change there? No, points. So that means when you compare it, the climate change scenario to the business as usual scenario, the difference that we expect is the points there we are talking about. So by 4.58 over the long run, value added for the economy 4.55. Then we see employment, government income, household income, and household consumption. All of them will decrease by different magnitudes. But it's important to point out here that household income is expected to suffer the least from climate change over the long run horizon, to decline the least among them. The only thing I can infer from there is that household income tends to be more resilient in Rwanda than the other major macroeconomic indicators, meaning things like autonomous adaptation, that's the one devoid of interventions from the state. We really help the household system to find ways of coping with climate change. So let's look at the breakdown of the effect on GDP. We've measured that GDP will decline or expected to decline by 4.8%. But how will the major sectors of the economy contribute to that decline? We have three major sectors: services, industry, as well as agriculture. We see that the bulk of that decline will be coming from the agri sector, 69.8%. So agri is going to, the decline in agricultural productivity is going to be very damaging to the GDP. It will explain almost 70% of that decline, followed by the services sector, which is about 25%. And then the industry sector will contribute the least, which is 5%, to the decline in GDP caused by climate change. Now, let's look at the impact on employment. So we just look at the different labor types: low skilled, high skilled, and medium skilled. So we see that the low skilled labor will likely weather the storm better than the other two categories of labor. We see low skilled labor unemployment that they will suffer there will be by 3.3% over the long run, but the other two types will be 3.8. It's identical. I don't know why, but that's what the data is saying, that it will impact medium skilled and high skilled labor by about the same amount over the long run. And we will look at the share of employment earnings by labor category and economic sector in Rwanda. How will it spread in terms of impact now? So in the long run, 38% of all earnings of low-skilled workers will be accounted for by the agri sector. So I didn't interpret all of them, but if you look at this lower part of it, the blue part, so 38% will be earnings of low-skilled workers will be coming from the agri sector, 28 will be coming from the industry sector, and then 35 from the services sector. But a striking result there is the 80% you see up there. That one shows that 8% of all earnings of high-skilled workers will be accounted for by the services sector. So it suggests that over the long run, and given the climate change scenario, most people will earn their income from the services sector in in Rwanda. So I think that's consistent with what you find in emerging economies, where the structure of the economy will be changing. So we see it will shift towards services, and people will earn more money from the services sector, given the climate change scenario. Now, impact on household income. So we have 10 types: rural, urban, then we have quintile 1, 2, 3. So the lowest quintile is 1, the highest quintile is 5. By way of categorization, the lowest quintile is those with the lowest income, the lowest 20%, and then you just break them down into 20 percentage points, and then you get up to 100%. 80 to 100 for maybe quintile 5. So here now we see overall income will decline by 1.8% percentage point compared to business as usual. For rural area, that would be by 2% percentage points, and for urban areas by 1.6 percentage points. What that means is that rural area will suffer greater income decline than urban areas. Again, the explanation of that cannot be separated from what we showed earlier on, that the agri sector is vulnerable, and we know most rural dwellers are into the agri sector. So they will suffer greater income loss than those in urban areas. And the lowest quintile, the poorest group in the economy, are the ones that will suffer the most. Rural area will lose 2.9% of their income over the long run, and then urban area 2.8. They are close, but that difference will still be much. And then we see the richest group will suffer the least income loss, both in rural area and urban area. So they will fare better. They are expected to fare better, maybe because they have wider range of sources of income. Most rich people will have investments, so they don't rely on those. So that would help them in proving more resilient to climate change. Now, household consumption. So shifting from household income to household consumption, we see a similar pattern, but not exactly similar. It's still different. And so the most disturbing for me overall is the decline in consumption by rural households, where we see about 5.2% drop in household consumption. When you compare that to the decline in consumption by urban household, it's just 1.9% we are seeing, over is 3.7%. If we want to find explanation for this, I don't know how many of us are economists, but to see that when your income is rising, you spend a lower share of it. There's a theory that explains that when it comes to income hypothesis. You see a lower share of rich people's income is spent on consumption. So if your income is dropping, the tendency is to push more income to consumption. So that probably explains why we see that the drop in consumption for urban dwellers is quite smaller than that of rural dwellers. It shows that rural people tend to spend a larger chunk of their income on consumption. So if the income drops, then consumption is in trouble. They don't have a space, a more space to adjust.
Here's an explanation might be because the rural people depend on their consumption depend on their own production.
Yes.
If
So
their own
that's
production
subsistence.
declines, then they will suffer a lot.
Yeah.
But for urban people, they depend on the market. Right? Yeah.
Excellent. So we also see that this subsistence practice in the rural area is very high, where people consume most of the things they produce from the farm. Okay, so but again, the distribution of the results across household quintile can be seen. It's shown. Let me not waste time. I've explained the other ones so that I can complete the presentation on time. So we move to the big issue, the adaptation part of it. In terms of response, we have seen how it will impact the different sectors of the economy. The next question is what can be done? I mentioned autonomous adaptation. That one is at individual level. But when the government is interested, then the one that is policy driven is what we're interested in here, where government can assist or provide support in devising ways of coping better with climate change. There are four that we included in this analysis. Soil and water conservation, that includes reduced tillage, terracing, ridging, ponds, and then mulching. Then the use of improved varieties, irrigation, and the use of organic and inorganic fertilizers. Empirical evidence on the impact of these adaptation strategies on crop yields were obtained from research results, so existing literature, but we ensure they are peer-reviewed just to make sure that they are reliable results. And so we present that in the next slides. Adaptation scenario, one we picked from soil and water conservation, we saw that it will impact on crop yield or crop productivity by between 4 and 46%. So it will help improve productivity if you adopt these two interventions, soil and water conservation. Okay. Then for terracing, ridging, and bonds, it will increase crop yield by about 44%, not between please. And that's for a study for Cote d'Ivoire by the World Bank. As then mulching increases crop yield between by 46%. And then soil and water conservation again increases maize yield between 14 and 50% in Africa. So the references are there. Now, what we simply did was to pick that range, that interval, and then we'll plug it into the model because it's a stochastic model, so it will run and then bring something in between that is optimal for the economy. So the next intervention is improve varieties. So what we find there is between 10 and 53% for all crops, but for maize specifically between 20 and 63%. And these are the studies to back up that. Then we have irrigation between 10 and 57% for agricultural crops in general, and then you narrow that to rice, it's about 23% improvement in crop yield. So that's what we plugged into the model. So, and then finally, organic and inorganic fertilizer. Yes, we know that if you pick inorganic fertilizer, it can be contentious, but then we have said that it's still an adaptation measure that can be considered. So if we apply it correctly, then we expect between 20 and 53% improvement in crop productivity. And so that was what we plugged into the system to produce our results. So let's look at the results. So the adaptation simulation result provides some insight into the investment requirement that will be needed to compensate for the economic damage attributable to climate change, shocks on crop yields in Rwanda. So we show that result in the next table. So here it is. So what this result is saying is, if we want to reverse the negative impact of climate change on agri and then on the economy, there are measures that should be taken. Additional crop area to be cultivated using these different interventions. So pick the first one, soil and water conservation. 24% of cultivation area, additional cultivation area should include this intervention. So investment should be made into soil and water conservation to cover an additional 10% of cultivation area. And then for improved varieties, that should be 20% additional cultivation area. So the investment should target that. For irrigation, 19%. And then for the use of organic and inorganic fertilizer, 20% will do the job. So that's what the result is showing. And so if it's to be used for policy guidance, that can give the government an idea of how much investment is required to undo the damage of climate change over the long run. So summary and conclusion, we are concluding. So using economic simulation models, the study has shown that climate change shocks potentially has adverse consequences on the economic growth of Rwanda. And that's because of the extensive reliance of the economy on the agri sector, of course, not only agri, but other climate sensitive sector, but mostly agri sector. Now, efforts to sustain desirable economic growth trajectory in Rwanda will require building resilience to climate shocks. Now, Rwanda, though, that has put in place a lot of measures as response strategy, but simulation results shows that climate change will continue to pose damaging impact on the agri sector and on the economy in general, unless effective adaptation measures are put in place to stem this undesirable effect. So based on this analysis, we state here that if the country continues on the path of business as usual, so without bringing significant adaptation measures, then it won't be healthy for the overall economic performance of the country. And so the following recommendations are considered necessary. One, scale up best practices related to institutionalization of agricultural, of climate change actions, and then fund such efforts. Mainstreaming adaptation practices in the agricultural sector will require improved prediction capabilities and a better knowledge of climate suitability for crops. So this one is very important. Remember, we said climate change is long-term view of the economy, but we also need to have an idea of the variability, the shorter term variations in the climate that is due to the changing climate. So if there are improved prediction capabilities, which can be resolved by those in the sciences, that will help. And then to know which crop, don't just plant crops everywhere, the one that is most suitable. So to avoid the traditional means, but now look at the reality of the day and be more realistic in planting. So the crop climate suitability will, based on the predictions mentioned above, indicate suitable places to grow specific crops based on the changing climate. Now, both inputs will help in adapting to a changing climate rather than relying on only traditional knowledge of the crop calendar. Finally, the study advocates for the promotion of climate smart practices such as soil and water conservation and of course, promote the use of irrigations and improve agricultural technologies to protect the productivity decline in the agricultural sector and hence shield the entire economy from climate-induced crisis. On this note, I want to say thank you, while I will happily welcome comments, contributions, of course, criticism of what has been done. That will help improve the work. Thank you.
Yes, thank you. Yes, please, Giselle.
Before we start for the questions, I just want to make clear two things. One, when we say that climate change reduce the country GDP by 4.58 percentage points, we mean that if the country was growing without climate change, like for example 6%, then the growth will decline to 6 minus 4.5. The growth will be only 2%. That doesn't mean that the economy will not grow. The economy will grow, but the growth rate will decline by 4.58 percentage points in terms of because of climate change. That is the interpretation I want to make clear. It doesn't mean that the GDP will decline by 4%. No, it's not. The growth rate will decline. Yeah, the growth effect. That's one comment. And the last one on the soil conservation, irrigation, and all this, the adaptation options. This means that if we want to reverse the effect of climate change on the economy and agriculture, we have to increase our level of investment by those percentage points in different areas. For example, for irrigation, currently we have about, I don't know, 68,000 hectares or 68,000 hectares for Rwanda, something like that. Then we have to increase this by 90% in order to compensate the loss we are facing due to climate change. Those are the interpretation. I just want to, you already mentioned those things, but I just want to emphasize on those points. Thank you.
Those are two very good points. Thank you very much, both Michelle and Henry, for the very eloquent presentation. I wanted, before we take questions, to check something. When you talk about adaptation options, are we still talking about the adaptation pathways, just to make sure that we are speaking about the same thing? Because these words, people can use them interchangeably.
So they are basically the same.
Okay.
The way to go.
Okay, good. So first question, yes, be succinct, specific, so that we can try and yeah.
Thank you so much. Let me first commend the presenter for the good job, well done. I have 3 questions, and they all of them relate to the model, especially the CGE model that he presented. The first one is on how we establish the benchmark for calibration of parameters. Since CGA model requires that. Yeah, you talked of literature. Did you entirely rely on literature for calibration, or you also consider other options? That's one. 2, how did you incorporate the climate change proxies? I didn't quite get the climate change proxies that you used in this model. Again, the last point is on, I didn't see multi-pointed variables incorporated in this model. So how can these variables, especially inflation and interest rate, be incorporated in the CGE model? Thank you.
Samban?
Okay.
And then Dr. Adubert.
Okay. Thank you, Henry, for the presentation. I have just a few interventions to understand more this model. My first question is about the climate change scenario. I would like to know, can you describe this scenario? When we talk about climate change scenario, can you describe this scenario, or what is achieved for this scenario? I would like to understand. And at the last of your presentation, you are talking about option for adaptation, okay? And you show it as 4 options. And would like to know, in terms of implementation, if you use one option by one option, if you test one option by one option, and if it is the case, my question is, if it is possible to test simultaneously the 4 options. If it is possible to test at the same time, to introduce at the same time these 4 options in the model.
Thank you.
Thank you.
Let's take.
I have 2 questions. If you can bring back the table on crops. I'm interested to.
Can you please?
I didn't understand, especially the rice. They are comparing the business as usual and why is affected. And there is a I've seen, they seem not clear to me. Because of rice, especially rice, I've seen business as usual, we have a value, a negative value. And on the climate change, we have a positive value. Can you explain? The second one.
Yes, that's the Nigerian one,
Put it on presentation board, please, so we can.
Yes, rice.
Yeah, price why rice is negative.
Yes, that's the first question. The second one is a combine organic and inorganic fertilizers. Is it possible to separate the two? Why did you combine?
Which one, please?
Fertilizers.
The fertilizer.
The fertilizers.
You combine organic. Okay, let's allow the presenter an opportunity to tackle these questions, and then we'll go for a second round. We'll come back to you. Henry?
Okay. So can I answer from here?
Yes.
Okay, thank you. So thank you everyone for the comments and the questions. So I couldn't pick the names of persons that asked questions, so I just numbered them 1, 2, 3. So there I got 3 questions. So for the first person, CGE model established benchmark for calibration of parameters. And then how did you integrate the climate change process? Then inflation and interest rate incorporation into the CGE model, whether that is possible. Okay, so the benchmark for calibration of parameters, those ones were basically, they were based on the baseline values that we got, and that's either from the social accounting matrix, which is the data on Rwanda for 2021, or we use, if it is not available there, we can calibrate based on those baseline data or benchmark data. Then you use external source. And the external source we used, we got the data from Food and Agriculture Organization. So they are long-term data for that period. Then we simply took the average of the mean. So we take the variations and then take the average. So you get a single value. So that was all we plugged into the model to be able to get those the benchmark data which were used to calibrate some of the parameters. Then how we integrate city process into the model. Well, like I said, for business as usual, we have data from FAO, data on productivity or average heat for those number of years, about 23, where we took the averages of the variation. But for climate change, that was based on simulations from the system now. So when you shock that, it will produce the values you see here. And then there was a way we fed in the values from the literature also. So we collated all of that, and then that helped in arriving at the climate change data that we see. Then inflation and interest rate. Well, this is a model of the real economy. So it's not a financial CGE. So usually you can have a CGE that deals with the real economy. And then you can also have a CGE that is financial. This is not the financial type, so we are not able to bring in inflation and interest rate into the model because it's the risk economy we try to deal with here. So that can be taken as part of the limitations of the model. So the next person asks of city scenario, what is climate change scenario? So that relates to the question that was asked earlier on. The climate change scenario was obtained from what the literature says is the impact of climate change on the economy based on crop productivity changes from different studies. So we collated all of that and then made use of that information. That was what we fed into the system as climate change scenario. Usually, some persons will want to use the key indicators of climate change like temperature, precipitation and all of that, how much increase in temperature has occurred and all of that. But for this, we came in through the agri sector being the major pathway that climate change is impacting on the economy. And what suffers in the agri sector is productivity. So it's crop yield, whether from the data or changes in the crop yield from the literature, from what other studies say. So from the data is business as usual. From the literature, we took that as the impact of climate change. Then adaptation option. Can we, or whether they were used separately or it can be tested together at the same time? Well, we tested them separately to know the individual impact of these options on the economy. It will be difficult to test all of them together in the model, because if we do that, then we'll not be able to test specifically what should be done to each option. And for policy purpose, I think that will simply model up the whole thing. You won't be able to advise on steps or measures to be taken by the government at the end of the day. So the model was designed to take them separately. So it was step by step. We looked at soil and water conservation first, and then put those brackets there and run it, then it will give you the optimal level. And then we repeated that for the other three options. So that was what we did. And the way the model is designed, we cannot lump them together. Otherwise, we will not be able to tell what is driving the results that we obtain. Then the fertilizer, is it possible to separate the two? That is talking about organic and inorganic fertilizer that we used. It's possible to separate the two if we can get the evidence from the literature. So if the literature is saying the use of organic fertilizer, we saw some of them in the presentation. So if we see the statistics, then we can actually use it. But here we combine them. But it's possible to separate the two if the data is available from the literature that guided the modeling exercise. The question on rice. So, well, what we have here is the agricultural value added from the entire agri sector or from a particular commodity. So for rice now, We are saying that if we follow business as usual, then it's expected that the rice production or rice productivity will continue to increase. But if you follow climate change path, based on what the literature is saying, rice productivity will drop. So, I mean, average productivity, because the mean value that we picked there. So,
He's asking why.
No, yeah, let me, no, it's the other way around. No, let me say this.
What?
That is the value added. It's not a productivity. Yeah.
Oh, so yes, it's value added we are talking about here.
Yeah.
So that's talking about the contribution from those inputs now. That's what value added actually cover: labor, capital, and the rest of them. Those direct inputs. So not the total productivity.
Yeah, it's because, you know, this value added calculation is productivity times area and times price minus the value of intermediate goods. That is the formula. So productivity may not, under business as usual, the value added for rice might be declining over time because other commodities are more competitive and the price might be declining. And then the farmers are shifting to other crops because of less areas and all these things. Those are the possible reasons for reduction under business as usual. But in terms of climate, when it comes to climate change, because rice is usually grown up in irrigated agriculture and all these things in wetlands, it may be less affected by the climate change, and then more area will be allocated to rice. And then the value added rather increases. So, I mean, here value addition. The value addition is, it also considers the amount of area allocated for that specific commodity. So, even if the productivity will decline over time because of climate change, but the area might increase compared to other crops. And then the value addition from that sector will be higher, even if that is the case. I mean, that's because the productivity decline may not be as worse as the other commodities. All these things is because the model itself chooses the best. Because the model, when you just run it, it chooses the best crops that provide high income for the farmers. And that's why under climate change scenario, rice will be more profitable and more valuable for farmers, so that the value added in the total, the sum of all the farmers' value added will be higher. That might be one explanation. That's might be right or wrong. Yeah, because we are talking about the value addition. That's price times area times productivity minus the intermediate product.
There was one question from Saman about the options, the 4 options that you presented.
Yes.
I'm not sure if your answer, can you project that please, as we answer, we see you have the various.
Yeah, he has answered, actually.
Yes, I followed, but I was not sure if it was there.
Yeah, the question might be a little bit like this. Which one is better for the farmer, for the government? If the government wants to choose, which option is better? That is a different question.
Yeah.
Because you have to consider the cost of implementation.
Yes, let's assume that the fund is not an issue. The government wants to fix the problem.
Okay.
And to bring everything back to acceptable level.
So you can choose one of them.
No, I'm saying the government doesn't want to choose. The government says we have the money to address the issue. Conservation agriculture, irrigation, blah, blah, blah.
That's fine.
Yeah, that's why I'm saying that the answer probably had to be nuanced a little bit for us to see. Because the answer is saying that the government has to choose. And I'm telling you that the government doesn't have anything. It doesn't have an issue about choosing. The government is saying that I have enough resources, but that I can channel towards addressing the issue.
No, but if you have enough resource, I think this is what we are doing. If you want to invest for adaptation, you can invest either of them. Then you can reverse the impact of climate change on agricultural productivity. You can reverse. by investing in one of them.
In one of them.
In one of them. But yeah, that's what what he said. If you want to invest more, then you get more.
No, the invention that one got after
I think, I think, I want to ask, among the four, which could you advise the priority?
Yeah, that is what.
For the government.
Yeah, that one I think we discussed with Henry.
Yes.
It requires some additional work.
Bring up the results for the adaptation.
The last one.
Where you have those 4 bars. Good. Yes. So I think the question borders on this part. Like Getal said, it could be the cost implication of these interventions that will guide the government. Now, the model does not reveal that. So if we look at, let's say you need additional 10,000 hectares of irrigation or irrigated area. To irrigate 10,000 hectares may be more expensive than providing soil and water conservation for 10,000 hectares. So that will be a possible consideration the government will look at. So if we say we are advising, pick this option, not from the strength of information, because we don't have that data, to say this is what it will cost government. Again, if we leave the economics of it, and then government asks the question, which one will be much more socially beneficial to the agricultural sector? So more people will prefer that option. Again, government will work with that information if they have it and say, we will go for this. But what the model is saying is, or what we are saying, is whichever option that is picked, it will effectively reverse that 4.58.
And bring it back to the initial.
Yeah, zero it out, or approximately zero it out. That's what we're watching for during the analysis. So if you do 24%, for instance, soil and water conservation, it takes the declining economic growth percentage point away. It wipes it out. And so the economy is restored to that business as usual part, as if climate change didn't happen. So that's the way the model is here. And that's why the answer I provided earlier on was that we can't combine all of them in this model. Because if we combine all of them, then the shares will be lower. So you will need smaller share of cultivated area, underwater, soil and water conservation, smaller share of irrigated, improve variety, and then but we didn't go that way. In case government just wants to phase one, this is what it means.
Very good. Yes.
But sometimes can't, because suppose that you are in the desert country or the drought area. I don't think you will apply the first one for water conservation or when you go that way.
That's correct.
That's right,
yeah.
That's correct. Assuming it's drought.
First you need to irrigate because I don't have water.
So that's additional information the government can arm itself with in choosing the path to go. They are just pathways. They're pathways. So government can opt for any of them. And depending on additional information that they have.
I think before we leave
on the same,
I don't think each of these four will replace the three before. Because before this slide, you showed us how each of the four affects in a percentage. So when you tackle one of the four, that percentage up, the loss will be removed, but not the 4.58.
Yes, it is.
For example, if you apply fertilizers and you don't have what you get, that change cannot happen. So in order to achieve the 4.8, you have to apply the 4 to tackle the 4 strategies. If you don't tackle the 4 strategies and you tackle one, you reduce on 4.8. Maybe you go to 3 point something, I don't know. We could also have a weight of this on 4.85. That's my.
Okay.
Yeah, these are backed by experimental data, actually. I think Henry was presenting, may not be necessarily from Rwanda, but from other areas. How application of organic and inorganic fertilizer can increase yield, by how much. That one, it's not our work, it's just like obtained from experimental data. We use that experimental data into our model.
Actually, for me, that's where my concern was
Yeah.
allowed to come in.
Yeah.
The reference was used. Cote d'Ivoire.
That's very valid, yeah.
Honestly, I
Yeah.
think in Eastern Africa, within the tropical region, we have something that we can use as reference that is similar to the Rwandan. Yeah, even Rwanda, I'm sure there are some national studies that you could have maybe asked in where you can get reference to be able to select adaptation options that can fit better our context.
Yeah. This is a very valid, and we have been discussing about it. Yeah, we want to make sure first we are just modeling, and then we'll just try some of the available information. But it's just a matter of changing the numbers. Yeah, so we get it from Rav may have that data probably. Rav will have that experimental data.
Even NICF.
Huh?
NICF.
National study.
Oh, NICF. Yes. No. The NICF, we have analyzed all those data. I think those are survey data.
Yes.
Yeah, we need experimental data. Experimental data, because we have to make sure that how much irrigation can increase yield based on experimental data. That will be more controlled. Experiment. Rather for sure we'll have.
It's data approximatory just that have similar.
Or like media data, if you come here for Rwanda, the experimental data for Rwanda. Maybe you.
For Senegal, we are dealing with this.
Wait. It looks like there's a burning follow-up question on this one, and then we'll allow Henry to reply. Please.
Thank you. Just a follow-up on that. I'm aware that REMA has conducted the framework assessment, which encompasses some scenarios and adaptation options for different sectors, including agriculture. So I was wondering if this was, to what extent this was considered, or any of the data contained that process was used. Yeah. Just to follow up on that, because it could contain some of this data.
Okay, Henry, can you be straight to the point so that we can take the second round?
Okay. So I'm happy
to
this particular result is eliciting a lot of reactions and comments. The first thing I want to clarify is that what guided this part of the analysis was results from the literature. So if REMA has done some analysis, except it was some field work in a typical journal article manner that shows the impact, then we won't want to mix it up with this. But again, I want to mention that we devoted some, in fact, this part slowed down this work. With working with my partners from academia, we searched and searched, combed everywhere for data. We didn't see.
You could have visited us in our institution.
Well, I don't live here. I don't even know. But what you mentioned, my sister, so if you can actually help us with the data, it doesn't take much effort to adjust the data.
I'm sorry to interrupt. What this was mentioned?
So
the climate change scenario, it's a big
yes.
component of what you will get in the results. So if you're based on literature, we need to see the literature you used, because there are global climate models that try to reflect the climate change scenario for Rwanda. There are also downscale climate projections that were done by the NAP project in REMA in collaboration with the team. So there is no reason why we should use literature from elsewhere, except what we have here. There's no excuse.
Okay, but we will be happy to see any literature you may have, or get some link from you or your institution that would guide us there. we did our search and we had that difficulty. So, and it wasn't something done alone. We consulted. We're asking questions, looking for who could help us with literature on that. So we felt using results from proximate economies is not out of place. The climatic conditions are comparable. So that was the basic intuition here that guided the choice of the literature we used. First, Rwanda, that was a priority. Central East Africa next, and then where is possible SSA, we concluded was fine. So that was what we did, but sincerely, we will surrender to superior argument if we have the evidence. Thank you.
We have a couple of questions, a couple of hands here. Yes, you first and second.
Yeah, thank you. I was confusing when we were presenting that business as usual and climate change. Because I know that as usual, climate change is there. So for in agriculture, I would love to see the antecedent or preconditions so that these crops is going to be vulnerable to effect of climate change. The other thing is that, of course, you are contributing to NDC, and these involve the cross-cutting sectors, local government, and civil societies. So then, how are you going to translate those findings to, for example, corridors, to us, civil society organizations, so that we can transform those findings into workable projects? Thank you.
Thank you very much.
Thank you. Mine is small, but the armed forces. You see, we are not staying here, but you may have seen on the landscape, we have a lot of trees. And I wonder if in your analysis, you consider the effect of trees on crop productivity. When you are talking of crop yield, how much are the crop yield influenced by tree crop interaction? We have trees that are facilitative. They increase crop yield when the trees and crops are grown next to each other. You have trees which are very suppressive, like eucalyptus, which has been recorded one that they can reduce crop yield up to 80%. Now, I wonder if you considered trees and wood crops in your analysis. Even if you did under, for example, soil and water conservation, which they can play a role. I don't know if you consider them under that. Did you consider that under this yield reduction for different crops? Thank you.
Thank you. Henry, please.
Okay, so work with CSO, civil society organizations, to produce, is it disaggregated results? Is that what we're saying? Who asked the question? I guess it was you. So is that the question? Or I missed it up?
It's not a question, it's a comment.
Oh, was it a comment?
Yeah.
Oh, okay. So thank you for the comment. In developing this model, like I said earlier on, we interacted major tools, the CGE model and the PMP model. So the CG is basically nationwide. So that database you find there is in the social accounting matrix is nationwide, so it's aggregated, heavily aggregated. So using that, we may not be able to speak to the peculiarities of different regions, different groups within the economy. So, but when you come to the PMP, that is heavily disaggregated. So the hope was we would be able to produce results that are region specific. I think we have 30 regions in Rwanda, am I correct? So we captured all of that, but there was an issue. So we don't have enough data to produce these aggregated results for the regions so that we'll be able to show the peculiarities of each region vis-a-vis the climate change effects. Assuming we were able to do that at this stage, it can be done later on, but that will be based on having regional social accounting matrix, so like 30 different data sets. And who will build that, I don't know. But if it's available, then we can push it to that level. And then if we have CSOs that also attend to these different regions, then we will be able to produce, work with them for them to validate the results we are getting vis-a-vis the area of their coverage. So that's my response to your comment, please. For now, it's national data we are working with, so it's having a holistic view of the economy. Then how much is crop yield? How much is crop yield influenced by tree crop interactions? I know my brother, that one, you are taking me out of economics. We don't.
But if yield crop yield is reduced, that will affect.
I so much agree. But what we do in economics, we make use of existing data. When it comes, these are scientific stuff that if we find people to generate the data for us, we can really pick them and plug into our model and tell you what the impact will be. But as long as that constraint exists, then we are just blinded, or our model is blind to all those realities that you raised.
But we had one option, agroforestry and tree planting and adaptation option.
Yeah.
In addition to this, the fertilizers and all.
So yes,
we had it for Nigeria or something.
No, we didn't include that for Nigeria. No. So sincerely, we can't. I'm not sure that data exists. If it exists, we didn't see that. If we have it, we can. It's just the same procedure. If we see where research was done to show the impact of crop tree interaction on agric yield or crop yield, if we see that, we will pick the data and plug into the model, and we will get the results.
And give you a visual publication, which indicates how eucalyptus with increased maize yield in Rwanda.
Okay.
Especially from tree crop line.
That's excellent. So, but is it just one publication, or? Because usually we want to have a handful of them so that that bias will be minimized. If we use only one, then small sample bias becomes a problem.
I don't know. I'm sure I have one of my own.
Okay.
There can be some others too.
So you published that, you authored it. Was it peer reviewed?
Of course.
Okay. So please, maybe the references, we can get guidance from the references, but again, I would be surprised if the references will take us to other economies, not Rwanda, since we have preference for the Rwandan literature here or studies. So again, that would determine how helpful that document will be. But please, if you can share it with us, I'll be happy. Thank you.
There's one question that was not addressed from him.
What question?
The scenarios, how are these scenarios defined?
Yes. Please repeat it again.
So I was asking.
Don't stand, just say it.
How you have separated that the productivity of from agriculture when business as usual, and other side, and there is climate change.
Okay.
How come? Because the only thing I could be able to understand is that this change is happening because of the antecedent or extreme that happens.
Extreme what?
We are facing climate change. We are living in that condition. It's a business as usual.
Also, to add on that, you know how these scenarios are normally defined. according to IPCC, because we are talking of climate change. So normally we have like business as usual and then adaptation. If you adapt, and there are ways we define this. So we love to know how these scenarios will, the reference of defining these scenarios. Yes, please.
So like I said, okay, let me start from what his question. The baseline data we used was the 2021 Central Accounting Matrix. Okay, so what happened before then? Assuming nobody placed any attention on the climate change issue. Okay, we just simply looked at the data that was gathered for a long period of time. We used that as a business as usual scenario, or used it for the business as usual scenario. But after looking at that, we now said, okay, so let's look at those studies that generated data now, information. What did they say was the impact of climate change? Those are scientific studies. Unlike the data as it just occurred, productivity, crop yield, and all of that, they were just recorded. So that's the business as usual. That doesn't look specifically at climate change impact. So that's BAU. But when we looked at climate change impact on different crops, the same crop yield or crop productivity, then we took that as the climate change scenario. Then we got that from the literature, not from publications like FAO Stat that we used for the BAU. Okay, so I think that was the best case that was available to us for use in this analysis. We were not looking at temperature change, like I said earlier on, or rainfall change. We were looking at crop productivity because we anchored the analysis on the agri sector. And we know that both temperature change and increase or changes in rainfall pattern will affect productivity directly. So we captured that from there. What the literature says for us is what climate change impact is, because they are scientific studies. Then what the data says for us, those are the BAU. So that was what we did. Please, your question again.
As much as I remember, we have three scenarios. Yes.
So
for this assessment, we have only two.
No, we have the BAU scenario.
Yeah.
Then we have the climate change scenario, and then we have the adaptation scenario. So those are the three groups that we have. The climate change is just caused by different events, as it were. But the response has to do with the adaptation scenario. What steps the government is taking to deal with the problem. So the BAU was no climate change. We are not really accounting for that, but this climate change accounts for the climate change effect. And then government naturally will respond. And that's the adaptation scenario.
I just want to supplement what he said, maybe to make you understand better. He was mentioning the climate change scenarios that take into consideration the GDP population changes in the future. They are called representative concentration pathways, and they are used in various analysis. So it also has a business as usual scenario where no action is taken in terms of climate action. And then there are other scenarios, scenario 2.6, 4.5, I think 8, right? So I think you just wanted to know if there is even a possibility for you to read up on these scenarios and see if you can use this incidentally with what you did in terms of the numbers of climate change.
Okay. So that's important information that we can actually look at in revising the work and see if we can integrate it into what we are doing. So I didn't get that part. So it's something I'm not aware of, probably not within my scope of analysis. So I'll pay attention to it.
Yeah, I know those are partial equilibrium. They use a partial equilibrium approach. That's why they don't simulate the economy. They simply calculate the GDP impact and all these things. And mainly related with climate change. Climate change. For us, just if you look at the theory of change or just the impact pathway of climate change, the first thing is the climate, the weather changes. The weather changes. And then there are economic activity like crop production. Crop production changes. And then the crop production changes that have effect on economy. For us, we started from the crop. We didn't directly bring the weather change. The weather change, the effect of weather change on crop yield, crop productivity, it was done by different literatures. And we captured that one, how weather change affects the productivity of maize, the productivity of rice, the productivity of everything. This is given for us. It's not endogenous, it's exogenous. So it's given. Then how this shock, how this impact affects the whole economy. In our case, it's general equilibrium because we simulate the economy. We just have a sort of like hypothetical economy where we just change here, the price change, and then the people behavior change, and all these things. Then the banks change and everything works, and then price determined based on the price, and there are rational actors in the economy, they readjust their behaviors, their allocation of resources and all this, and then they do use output.
So if that's the case,
Yeah.
then you can pick studies that have done, established a climate change scenario picked from global climate models.
Yes.
And then also gone ahead to show the impact of climate change on agriculture, but within our context.
Yeah.
Eastern Africa, Rwanda.
No, that one is, that one itself, I mean, yeah, one of the problem we are facing, we have a lot of climate models. We don't have shortage of climate models.
Yes.
And the problem we have is on crop model. The crop model we have is very limited in Africa. These crop models, what they do is bring the climate change scenarios. Climate change have different scenarios. They brought into the crop model and they predict the productivity over years. That one, that is where we are missing. The crop model. I don't know agronomists, are they, maybe there are agronomists here. They can help us. Many crop modeling, we have tried to approach many of them. And in many African countries, the models, the crop modeling exercise is very limited. That's where climate change modeling, we have models, you know it better than me. And now we are adding economic models. But the economic model depends on the crop models.
I still believe there's somewhere you can do that.
Yeah, but I think we have to search it. I agree with you that we can approach the different institutions here in Rwanda, and we can get those data. And once we got those data, it's not really something. The most challenging exercise was the PM, that the positive mathematical programming. That is where we model for spatial distributions. But later on for Rwanda, even for big countries in Africa, we don't have some at district level for this. In many cases, we have at national levels. That's what we have, even I think, in most African countries. That's the challenge, but we took this, it's a good comment. Yes, you are right. It has to be, I mean, somehow reasonable and has to reflect the local context. And that's the idea. I don't know, I'm missing the chair. So the whole discussion is very interesting. We can continue on that. But I think lunchtime is also approaching, and we are postponing the next presentation after lunch. So it seems like Eric has one burning questions.
I have a question on all the presentation we made, then the discussion among the colleagues. When you're doing the business as usual or projection of what you have seen on the GDP implication of crops and everything on all the methodology you can do, did you consider Rwanda we don't do anything on this? So did you consider any of the work that is being done today? Because there are some projects, there are some activity that is now ongoing. For example, if you consider this for your business as usual, like we don't do any, for example, soil and water issue, we do soil and whatever, or you consider what we have today as a business as usual. Because today there is some areas where we have the soil and water conservation, and some other of this activity that's now mentioned to reduce to increase or reduce the negativity of our GDP.
Yes, you are right. It's based on 2021 sum. That means, I mean, we are very much technical maybe. Sum means taking everything the current level, the level of every technology available, productivity level, and all these things. Sum means the baseline is 2021. We took all those things. And all our suggestions, for example, if you have to increase irrigation by 90%, we are meet that the level you have in 2021, and then increase this by 90%.
But we don't know what we have today as 2024.
Where we have the data, 2021?
2024.
No, 2024. So the sum has to reconstruct. Sum means the economy. The economy has to reconstruct. Simply, it's not only irrigation. We have to have all the GDPs.
But 2021 was like with COVID.
No, by the way, in terms of sum, is the latest one. We had many countries that we have before COVID.
But to get out, the only issue, you say baseline. Baseline
21.
But you are dealing with climate change. 2021 up to this year, or if you have considered one, this is not about climate change.
No.
Climate change is about the long term.
Yeah, it's not.
So how many years have you considered?
Up to 20.
This is the main issue. How many
22 years.
22 years.
Now, 2021
up to 20.
2021.
2000 to 2022.
Now it's reasonable.
Yes, inclusive.
This is reasonable. But my sister was talking about the pathway, the ones you should consider. But nowadays, there is also some modeling of the SSPs, shared socio-economic pathways. So these ones, if you want that, you want to have impact on economic, you should consider SSPs, shared socio-economic pathways. And in your studies, you didn't consider. And those data are unavailable.
It's free.
So there is RCP, she was talking about RCPs, but SSP is about economics. So please consider this result. Yeah. I
don't know those things.
Shared socio-economic pathway.
We'll see. But I know the IPCC is everything, they are partial equilibrium. They are just considering only the effect of climate change on agriculture, and then they multiply. Anyway, I don't need to explain their methodology here.
Okay, so I think we've covered all the key issues that the audience wanted to share with us. We want to thank the presenter once again for the very interesting lively discussion. And as Gitao indicated, we have made a slight adjustment to allow the next presentation that was due to come first when we come back from lunch. We can break now. How long do we take for lunch, Gitao? Taking into account the time.
45 minutes.
45 minutes. You will all be ushered to the restaurant so that we can spend time together. Hopefully, we will all be back after lunch so that we can continue with the 2 presentations left, including one from Gitao.
No, 2.
That's a bit 3.
No, I think my presentation can be postponed because it has been discussed several times.
So
anyway, we have 2 presentations, one on vulnerability assessment, the other one on mitigation pathway.
Okay, so when we come back, you will take over. Mr. Afra will moderate the next session.
Sure.
Thank you very much.
Thank you. Keep on your active involvement.
Thank you so much. So lunch is being served over there.
It's there.
Is that no? It's fine. Okay. Good idea. But we are able to, and we compare notes as you speak. And I was glad to see people exchanging business cards and contacts. That's with the spirit of this seminar. It is really a knowledge seminar. Because people in this room are experts, them. So that's why we take care of listening and taking note of people's messages.
So in this circumstance, it is on household vulnerability to climate change at national and district level using the 2021 NISR survey data. So for this presentation, two people present, Dr. Gita, they say, kind of giving a hook, presenting us the hook, and Sambanya, Sambanya will just carry on. So Gita, if you are ready, we can just start. Thank you. So
Thank you, Gerald. Presentation after lunch is usually challenging, but I'll try and, I'm just giving you some introduction, and then someone is the one who's doing this analysis, and you continue to explain us his methodology, some of the findings. And basically, vulnerability assessment is not something new for most of you and most of us who have been involved in different climate change research and all these things. So I think Rwanda is also one of the pioneer countries where they do regular vulnerability assessment. So REMA is also especially very much clear that REMA is responsible for this one, but we will also try to develop and just follow the same methodologies, and we add our own inputs in the methodology. And also to test our methodology, we use the recent survey that have been conducted by NISA. So my introductory is that I think we all know that the whole issue, the whole analysis is stemmed from the Paris Agreement. The Paris Agreement in 2015, and this Paris Agreement has led for countries to develop NDCs and EPIs, and especially for adaptations. I think one of the key areas in many national adaptation plans is the reduction of vulnerability to the impacts of climate change by building adaptive capacity and resilience. And also, I think there are also issues related to mainstreaming adaptation options. So I think these are the two guiding background information that require the vulnerability assessment. I mean, because we want to reduce vulnerability, then you have to track whether we are being really enough or not. And the other one is we have to mainstream adaptation. We have type of adaptation, because the source of vulnerability might be different. And he will explain us the different dimensions of vulnerability and how to really capture those things. Yes. I mean, the goal is that they just estimate household vulnerability and all these things. And let's explain this. Rather, I mean, just to explain a little bit more about vulnerability assessment while we make it. Yeah, as I said before, it's mainly the first purpose is to track progress, whether we are making a good progress in terms of climate actions and building resilience, and in order to track the different commitments that have been proposed in the national adaptation plans. And also, I think it's very critical for targeting interventions. We have to target. If you want to reduce vulnerability at the national levels, then you have to see how vulnerability is across different locations and different households. I mean, vulnerability in a sense is household specific. It's more of an economic concept because it's just a household. Even if the climate change affects everybody equally, and our adaptive capacity might be different. So my neighbor might be more vulnerable than me, or I might be more vulnerable than the same neighbor in the same location, in the same community. So it's more of a household issue than the community. But the community also has some other issues depending on the source of the shock. I think it's also important to look at some of the social groups. But before that, I want to say the different types of vulnerabilities we are talking about. If you take the environmental vulnerability, this means physical damage caused by shock. I mean, for example, land degradation. Some lands might be more protected than less vulnerable than a shock
all these things. And biodiversity loss, all these are just environmental losses. And if you just translate into vulnerability, there are environmental vulnerabilities. Economic vulnerability is the economic damage due to shock, the same shock. We also have economic vulnerability in terms of income loss, as asset depletion or crisis, or in terms of productivity decline. And all these are just vulnerability to the economic vulnerability because the shock affects all these things. And finally, we have also social vulnerability. And some society might be more vulnerable than the others in terms of displacement, hunger, disease, and all these things are social damage that we expect from a shock. So depending on the type of damage we get from a shock, we can measure environmental vulnerability or economic or social. In our case, it's mainly about economic vulnerability at household levels. And the type of vulnerability is different because some people, they were measuring vulnerability of households for the pandemic, the COVID-19. The vulnerability for the pandemic is different from the vulnerability for climate change because the type of households being affected and all those things, and also the impact pathways are different. So some climate shock is just like different from the other shocks. For example, we have also market shocks. Africa might be more vulnerable for climate and health, but we might be more resilient for market shock because we are not very much integrated. That's why, I mean, it depends on the shock. So whenever we are vulnerable to climate change, and we are vulnerable maybe to health shock because we have very limited infrastructure to cope up with the shocks. Otherwise, for market shock, I think most of you, if you remember, the shock we had in 2007, 2008, this is the global food price crisis. And it took Africa was immune somehow, but the other countries, they were very much affected on those financial crises and all these things. Sometimes, I mean, people from the banks, they understand very well how financial volatility affects the economy of the Western economies, but African economies, somehow they are just vulnerable for those type of shocks. So these are just, I mean, just contextualize when we are talking about here, we are referring to the climate shock and we are referring to the climate vulnerability. And also this, but even climate vulnerability can be measured at different levels. At economy-wide vulnerability, for example, how the economy is susceptible as Henry presented, and how they really assess macro level effects, the macro level, maybe without going to the household level. And at community level, we can also measure vulnerability at community level in terms of like taking some infrastructure issues, because most of the infrastructures are common for all the people in the community. So we can also measure, especially when we measure vulnerability for health shock, we are always considering mainly at community levels. We are not at household levels, it's based on the household assets and all those things. So these are some of the preliminary things to consider. And then I think once I gave you this background about the different, in our case, we are measuring household level for the shock to climate change. So how do you measure it and how to assess this, and which is very much consistent with CACCI methodology, and then someone will explain for us. Thank you.
Thank you, Jota, for giving me support. Samban Yad, Associate Research Scientist in Agriculture 2016. So in the rest of this presentation, I'm going to talk about the methodology and some key founding results. So here, when we talk about vulnerability assessment, it is important to ask three questions and try to answer these three questions. One of them is who are vulnerable? It is the first question when we do assessment exercise. Who are vulnerable? The second one is to what? And the third is where. So why this three question is very important. The first question, who are vulnerable, will help us at the beginning of our assessment to identify clearly the unit of assessment. As Jeta said, we can analyze vulnerability at economy-wide, we can analyze vulnerability at community-wide, at community level. We can also analyze vulnerability at household level or individual level. So at the beginning,
it is important to clearly identify your unit of assessment. It is a first question. So for the second one, so this question also is very important. Why? Because here we see that we have different type of vulnerabilities. We have economic vulnerability, we can have political vulnerability, social vulnerability, or health vulnerability. So when you do this exercise also, it is very important to define which kind of vulnerability we are talking about. So this question will help us to define clearly which vulnerability we are working. And the last one is where. So this question is the last question where it is important for the policy maker in the sense that we are talking about vulnerability. So the answer of this question will help us to identify where we will found units which are vulnerable or the unit who are vulnerable. The answer of this question will help us to identify this unit, and so it will help policy intervention. It will help to make more efficient policy intervention in the sense that we have located the position of the unit who are vulnerable. So we have these three questions. So for the next part, we will try to answer each of these questions in our methodology. For instance, for the first question, who are vulnerable? As I said, in our exercise, the unit of assessment is household level. So here we are at the household level at the unit of assessment to answer the first question. Now the second one is which kind of vulnerability we are talking about. Here we are talking about climate change vulnerability. It's very important to be clear at the beginning. We are talking about climate change vulnerability, and here we have the definition given by the IPCC. So according to IPCC, climate change vulnerability is the extent to which the natural or social system is likely to be damaged by the impact of climate change. And so according to the definition, climate change or vulnerability to climate change is a function of three components. We have exposure, we have to take into account sensitivity of household, but also we have to take into account adaptive capacity of household. So it is this three component explains vulnerability of household. So here we have the answer of our second question to what we are talking about climate change vulnerability. So the last question is where we will find units who are vulnerable. To answer this question, we develop a composite index called vulnerability to climate change. So we develop a composite index drawn from the integrated research framework on climate change of Rwanda, but also guided by the conceptual framework of IPCC. We use this true information to build our composite index of vulnerability. So if we compute this index, we will have or we will get the level of vulnerability, and the level of this vulnerability will help us to identify where we will find in the country or in the district household who are vulnerable. In the sense that policymaker, we will help policy to we will help to make more efficient policy intervention in this sense. So here, how we proceed? For the methodology, we have three components, as I said. We have the exposure component, we have the sensitivity component, and the adaptive component. And what we would like to do is to get this part, the vulnerability. So here we have to compute the first two components, exposure and sensitivity, in order to get the potential impact of vulnerability to climate change. So if we know now the potential impact of vulnerability, but we should also take into account the adaptation capacity of household, because we have a potential impact, but households have adaptation capacity. So we need to take into account this adaptation capacity. So if we take into account this adaptation capacity, then we will identify which households are vulnerable or are not vulnerable. Because we have the potential and we know if the household has the adaptive capacity or didn't have the adaptive capacity. So by following this way, we can compute our global index called vulnerability to climate change. So here I would like to explain more theoretically how we can proceed to compute the index. So here we have our global index, the vulnerability to climate change index. As I said, we have here three components of vulnerability. We have the exposure, the sensitivity, and adaptation capacity of household. So what we do, we need to take, for each component, we need to identify some kind of indicator. So if we identify indicator for exposure, indicator for sensitivity, indicator for adaptation capacity, in order to know the level of component. So here we will compute the average, okay? We have here the average value of each indicator, the average value of indicator that we find in explosive component. Here, for instance, before computing the average, we need to, I told you this one, we need to normalize the value. We need to normalize indicator value. And here, I will show you after what way we do to normalize the value. But here we should normalize the value of each indicator. And so if we normalize the value of each indicator, for each component, we just compute the average of this indicator. For instance, for explosive index, we compute the average of indicator of explosive component. For sensitivity index, we did the same exercise. We compute the average of sensitivity indicator. And for adaptation 2, we did the same work. So now we will see how we identify indicator for each component. In practice, how we identify the indicator here, for instance, for the case of explosive component, we have some indicator. But how we select this indicator? We select the indicator according to the definition of this component, but also by the conceptual framework developed by IPCC. Here we develop, here the definition of explosive is, explosive refers to the magnitude of climate variation which households in a district are expected to face. So according to this definition, and according to the review and the conceptual framework developed by IPCC, and the available of data also, we select 4 indicators okay, to compute the level of exposure, household exposure. Here, for instance, we have 4 indicators. We have the level of drop or irregular rainfall. We have also the level of flooding, the level of fire, and also heavy rainfall. So we select this indicator according to the availability of data set. So now, if we identify the indicator for each component, what we would like to get is, we would like to get the exposure level. Exposure is a exposure. Okay, here. So we have the exposure. And what we would like to check is the level of exposure for each district in Rwanda. It is what we expect to get. And how to get it, the process. The process is here. We have to identify, first of all, for data set, when we will find this indicator, we have some kind of indicator. And so we need to identify all data set where we found this information. And so if we have this information, we just need to tabulate, okay, the level of each indicator for each district in Rwanda. As an indicator, we have to tabulate the level of the indicator for each district in Rwanda. So by this way, we will get this first table. And now we move for the second table. Here we have the normalized value, okay, of this indicator. And how we proceed to get this normalized value? By using 2 steps. The first step is to use max mean effort. Use max mean effort, okay? Which is I will explain you max mean. We already know this effort. But the first step is to use the max mean efforts. And if you use the max mean efforts, we need also to take into account something very important, the sense of correlation. The sense of correlation, let me come back here. Here, we have to take into account the sense of correlation to compute our global index. How it works? We have here some kind of indicator, and we need to compute our global index. So why we here, for instance, for the first indicator, the level of drop, we assume that we have a positive correlation between the level of drop and the vulnerability to climate change level. It means the higher the level of drop indicator and the more vulnerability households are. It is the sense of this correlation. And it is important, and we have to do it for each indicator of the sense of correlation. So if you know the sense of correlation, here we should just take into account the sense of correlation for the normalization by this way. For instance, here, if we have a positive correlation between the 2 indicators, we have to normalize the value by using the system. If we have a positive correlation, and if we have a negative correlation, we will use this way to compute normalized value. And it is important. Why it is important to normalize by this way? It is important in the sense that it will help us to make easy the interpretation of our result. Because here we have some indicators are positively correlated with our global index, and other indicators are negatively correlated with our indicator. So if we didn't take into account for the normalization, if we didn't take into account this formula, at the end, interpret our result, we need each time to know the sense of correlation before interpret our result. But if we use to normalize by this way, at the end of our, we just say the higher the level of indicator, the more vulnerability household are. By this way, we just say at the end, if we have a high level of indicator, we will find more household vulnerability system. So here it is the first component. We did the same work or the same exercise for each component. For instance, for the sensitivity component, we should define the component of sensitivity. Here, sensitivity is for household case. Sensitivity is the case referred to the sensitivity case referred to the degree to which household may be affected by exposure to climate change. We have only with the first component and the second component. First component is the exposure of household, and the second component, sensitivity, we take into account the impact, the direct impact of household exposure. So for this component, we select also some indicator according to the review, according to the conceptual framework of IPCC. And here we will find some sub-index. For instance, for the two first index indicator, we get the indicator by taking into account the impact of household exposure, the agriculture impact of household exposure. For instance, we have here the percentage of household suffering of high grade of crop due to the exposure. We have also to compute the percentage of household suffering significantly drop in price of agricultural product based on the exposure level. It is the impact of agriculture. We need also, for this component, we need also to take into account food security. We have to take into account food security, and at the end also we have to take into account for this component access to water. Okay, if household have access to water or not, it's very important. Now here we use the same way, we use the same way to get the level of sensitivity for each district. Here for each district, at the end we have the level of each district. Now for our last component, adaptation capacity of household. Here also we need to take into account some kind of indicator. One of them are dependent to the level of knowledge, household level of knowledge. We have also some indicator dependent of the economic level, and also some indicator dependent to the livestock improvement. And here we need to take into account the sense of correlation. If you can see here, instead of positive correlation, we have here negative correlation because it is the adaptation capacity. Okay, we have the potential effort, and we need to minus the adaptation incapacity. So here we have, as a sense of correlation, we have here negative instead of positive correlation between this indicator and the global vulnerability indicator. Now, we proceed the same way to get the adaptation inability for each district. We have the level. So if we did this work, now what we need at the end of the day, we need to get the vulnerability to climate change and the level of vulnerability to climate change, first of all, for each district in Rwanda. Based on our methodology, we need to know the vulnerability level for each district. We also need to know the vulnerability level of economy-wide level. So for district level, we have just to close this way. We have the district here. We already compute the exposure level for each district. We already get the sensitivity level for each district. We already get adaptation inability level for each district. We have just to compute the average, the informed weighted average of these three components to get the vulnerability level for each district. Yes, I would like to mention here we consider we have adaptation capacity and adaptation inability. Here I take into account adaptation inability. That's why I use here. If I select adaptation capacity, I have to make here minus. Okay, here instead of plus, we will have minus. Okay, now here this way help us to get the level of vulnerability for each district. Now, how we can proceed to get the vulnerability in economy wide. To get this level, we need to take into account the weight of each district. We have a data set, and in our data set, we have household as unit of assessment, and we have also the weight of each household. So what we did, we compute here the weight of the district will be the sum of household weight. In each district, the weight of the district will be the sum of household weight in this district. And so here we need to take into account this weighting. And if we have this weighting for each district, it will help us to compute exposure level in economy-wide. Why? By just making the external product between, for instance, if we would like to get exposure level, we have to make external product between these two vectors, exposure and ponderation. It will help us to get exposure level. We did the same sensitivity and the ponderation. We multiply these two vectors to get the sensitivity level of economy, the sensitivity level. And also we do the same to get adaptation inability level. So if we have this information, exposure, sensitivity, and adaptation, we follow the same way. We have just to compute the uniform average, weighted average to get the global or the overall level of climate vulnerability to climate change, household climate change in Rwanda. So it is how can I say it is a practical way to compute the index. Now, let's see the result. But before the result, here, as you can see, we did also a classification or categorization. Why? Because indeed here, what we get is just the level of vulnerability. We have just the level of vulnerability. And it looks like that it will be important to try to classify district among the level of vulnerability. So for this exercise, we develop two ways. We have a relative categorization. We have also absolute categorization. And each of them have a specific goals. For instance, for relative categorization, it will help us to compare and prioritize the district of the country. For instance, by this way, we have the level of vulnerability for each district, and by this classification, it will help us to know among the districts in Rwanda, which districts are much more vulnerable, which districts are more vulnerable, which districts are low vulnerable, or which districts are much low vulnerable. But just for the country, it is a relative categorization. Now, for the absolute categorization, it will help us to compare the state of vulnerability to climate change across the country. We can compare across the country, but we can also follow the level over the year, okay, to compare. If the level of vulnerability for one district is, it will help us to know the level of vulnerability for each district. For instance, here, we will have for 2021, the level can be we will have very high level of vulnerability for one district for 1 year. And the next year, we can get high level or moderate level of vulnerability for this district. So this way will help us to compare the variation of vulnerability over the year or also across the country. Now let's show the result. Here we have the data. For the data, we use data came from Comprehensive Food Security and Vulnerability Analysis 2021. Our data set was provided from this source.
So as we said, for each component, we already identify the indicator. Okay, here we have the indicator for sensitivity, we have the indicator from the this data set. We have also the adaptation capacity from this data set. Now let's show you the result. So for our first result here, we can say here, according to this graph, climate change vulnerability by component, we can observe that the level after comparing, we can say that the level of overall vulnerability we can say the overall level of household vulnerability in Rwanda is 1.44 on a scale of 0 to 1. Just a reminder how to interpret this result. The closer the value is to 1, we normalize this value. So the closer the value is to 1, the higher the level of vulnerability. The closer the value is to 1, the higher the level of vulnerability. So here we have 0.44. It is just the level. So after that, we need to classify. What we can also get, we can see also, we try to see which component explain this result. We have 3 components. We have sensitivity, exposure, and inability to climate change. So here, according to our finding result, we see that inability to adaptation explain more household vulnerability for the case of Rwanda. We have inability to adaptation, followed by exposure level, and at the end we have the sensitivity component, explain less the vulnerability level in Rwanda, for the case of Rwanda. By this map also, we try to see the distribution of vulnerability around the district in Rwanda. In here, we can say, sorry for the spelling, we have Karongi, some districts. Here we show you the 3 first districts where we get the largest score of vulnerability in 2021. We use 2021 data set. So here also, as a result, we have the 2 districts with the least vulnerability households were Gasabo and Hero. Good job. Yes. Okay. So we get this information according to this map. So now what we will say, what we will try to see is what explains for each component. We try to see what explains this level of vulnerability. For instance, for the global vulnerability, we have 3 components, and we know that adaptation inability explain more household vulnerability. So we need to know for each component, for instance, for exposure component, what explain household exposure, what indicator explain more household sensitivity, and what indicator explain more household inability to adapt. Need to get this information. Okay, but before this information, here we compare also, because we get, according to the review, we have some information for climate change vulnerability in 2018. For the case of Rwanda, we have some result, the level of vulnerability for 2018 for each district. And for our result, we have the vulnerability level for 2021 for each district. And here the exercise is try to see the variation, how vulnerability, household vulnerability, the variation of household vulnerability between these 2 years from 2018 to 2021. And here we can say that on average, the vulnerability to climate change has declined from 0.49 to 0.44 or 4.3. It is 4.4, indicating that 5% of the vulnerability households have become less vulnerable and more adaptive to climate change within the last 3 years. Although the indicators used in the 2 years are slightly different, this decline may indicate that households are generally recording strong improvement in terms of reducing vulnerability to climate change. This is one way to interpret this table.
Actually, the 2018 is taken from the REMA.
Okay, from the REMA.
Yes, from the REMA.
Oh, so this is from the
2018?
2018 vulnerability assessment.
Yeah, 2018 we did the borrow test. We are comparing with our result.
We'll do another one this.
Yeah, I know. Yeah, but this is just to show you that it's also possible to do with the available data sets, but you continue doing those things. And in terms of methodology and all these things, we have some improvements here. We can explain them later on. Yes.
So here, as I said here, we try to see what explain household exposure to climate change. For our case here, we have some indicator, and here we see, according to the result, some measures of exposure among households in Rwanda is the frequency and intensity of irregular rainfall. Okay, for our case, according to the data set, we see that the irregular rainfall explain more household exposure for the case of Rwanda. We can also notice that the household in the district of in this district face high exposure to climate changes. Okay. At the other side, we can notice that household in the district of Gasabo, okay, Ritsiro, Lera also have the lowest exposure to climate risk, according to this map. So now, what about the sensitivity? Here we have also some indicators which help us to identify what explain more household sensitivity to climate. Okay, here we have access to water, which explain more household sensitivity to climate, and we have wealth index. We have also food insecurity. This index or this kind of information help us to know that this indicator explain more household sensitivity to climate. Here we say we can notice that the two major sources of sensitivity among households in Rwanda are the water access and the household wealth, according to the result. So the last part is adaptation issue of climate change. We do the same exercise. We try to explain. We try to see what explain household adaptation issue of climate change. Here we have some sub-index, and for this sub-index was compared to closer indicator. And here, what explain more household adaptation issue? One of the sub-index is human capital. If I say human capital, it is a knowledge. Here we have the human capital member of any association or cooperative, because if you are inside of within an association, you will get more information, okay, to prevent for climate change risk. Here also, human capital take into account the education level of household, okay, and access to climate information. So access to climate information. And here, what we can say, household have adaptation issue because most of them they didn't was within an association or cooperative, or they didn't get climate, they didn't use climate information. It is what we can get here.
This means that the adaptation index is low is because most of the samples within the house, our surveys, they don't have access for this type of services. That reduces the average level of adaptation.
Thank you. Okay. Now, here we show you some results based on classification or categorization. For instance, here we have the relative categorization for 2021, and the absolute. We have two ways to classify household level. Here we have the relative classification, and at our right we have the absolute classification for 2021. So here, what we can notice that for 2021, here according to this map, we can identify which among the districts in Rwanda, which districts are much more vulnerable, or which districts are more vulnerable or less vulnerable. For instance, here, this district in red color are much more vulnerable, and the district in green color are much less vulnerable, according to our relative classification. So on our right, we have the absolute classification. For the absolute classification in 2021, what we noted here that Gasabo, yes, Gasabo, the level of, we try to analyze the level of vulnerability for each district. And here, Gasabo are a very low level of vulnerability. Okay, we can say also Burera, for instance, or Ritsiro have a moderate level of vulnerability. And other hand, we have, for the other district, we have a high level of vulnerability in 2021. But as I said, we can compare because we have here the level of vulnerability in 2018 and we compare the level of vulnerability for 2021. And now here we can see how the level changed over the year.
So we're more vulnerable than 2021.
No, here it was.
No, they are now.
What's it now?
So it means in 2018, almost all the districts were
Exactly,
same
yeah.
level of ability, but on this one, there are some changes.
Exactly.
According to that, more.
Exactly. According to the data, here we have just some data, and I do the computer. We have for all the districts have high level of vulnerability in 2018.
They are in the same category because we use absolute classification.
Absolutely.
Yeah, that's why almost all belong to the same group. We can just simply compare, for example, this one with Senegal, with other countries. Because the absolute, in terms of absolute classification is the same, that we can compare across countries.
But relative then?
Relative is for the country itself. You have it, yeah?
Yes, I already, yes, I have a relative.
We didn't understand the word difference between relative and absolute.
Let me explain. Yeah, let me explain. Relative means you have certain districts. Yeah. And the ranking, you know, this vulnerability index is a score. It's not value. It's just a score. So this score has to be classified into high, low, all these things, just using the scale. So when you scale it, categorize it, you can use a relative in a sense. Here in Rwanda, for example, Gasabo, here is the lowest. That means the lowest. If Bugesera, I don't know Bugesera, that is the case or not. But if Bugesera is the lowest, then you give it 1. So relative to here, which districts, just ranking the districts here within Rwanda, that's the relative classification. Absolute is, we have the VCC, for example, from 0.2 to 0.3 is, we call it low, which is absolute. Whether it's in Rwanda, whether it's in Senegal, if they are belong to 0.2 to 0.3, they are low. And if you look at the absolute value, the maximum here is 0.57. You don't have up to 1. But some countries might have up to 1 in terms of absolute. Yeah, I don't know. Did you understand? Absolute is just like the classification, it's a classification. So you have an absolute,
the other,
yeah,
relative.
Okay. Here, for instance, we have the result for 2018.
This is the relative.
Yes, the relative.
You see every district is in the categories. You have green, you have light green, and you have the pink, you have the red, because the ranking is only for Rwanda.
So my question would be, for example, you have CACCI, it is in the green, 2018, and it's in red in 2021. Does it mean on the ranking, then it goes very low compared to
yes.
Here we
yes, please.
Okay. What I will say, according to these two approaches, here we cannot compare these two graphs. For instance, here, please let me compare. For this graph, okay, we have here 2 marks. According to these 2 marks, in 2018, we get some found result. Okay, and according to the result, if we represent this result by absolute classification, we can say at the end of the day, we can say for all the districts we have high level of vulnerability. But for 2018, but in 2021, we have the same criteria. So in 2021, we see that Gasabo, who have high level vulnerability in 2018, now have a low level of vulnerability. It is by this way we can compare these 2 marks. But here we cannot compare these 2 marks. Here what we can say,
They are all relatives.
It is a relative, yes. Here it is relative in 2021 and 2018. For instance, for the first month, we can say in 2018, among all the districts, we can say here, this district has very much vulnerability level. Here.
For example, it was the last one.
Yeah.
The ranking.
Exactly. On the ranking, there was the last for 2018. But now, if we come in 2021, we did the same exact according to the level of vulnerability on this year. And according to this level, we can say now for 2021, who is much more vulnerable. The rank of this district is I don't know if it remains the same. Huh? It remains the same.
No, they cannot.
It is the same information, but what I said, we cannot compare. Yeah, we cannot compare these two information. Why? Here we have an absolute. How can I say? We have an absolute certainty. If we complete our level of index, so we have two approaches. For the relative approach, we use Cummins approach. The approach wasn't no Cummins approach to complete relative classification. Okay. Now for absolute classification, we just need to identify some threshold and say for each year, if we compute the level of vulnerability, we have on some threshold, then we just need to see where is the level of this district among this threshold. You can see it is the absolute value. It didn't change over the year. The threshold didn't change over the years for absolute classification. I don't know how can I express it more.
It's okay, we can.
I think you can move.
Just to finish, for instance, if you gather all rich people, we can say among these rich people, this person is the rich. It is the less rich among these rich people. You know, he is a rich people, but among these rich people, he is the less rich.
He's a poor among the rich.
Exactly. So the relative class will help us to get this kind of information. Now, for absolute information, as we said, it is the absolute value. For each year, we have just to identify, for instance, your income and compare your income about some threshold and see if you are rich or not.
Okay. So for the absolute, the standard.
The standard. So we can compare over
beyond the standard, then or below.
Exactly. Exactly. But for relative, for each year, we will have these two classes. We will have these two classes for each year, because for each year, we will divide our population in two classes. So for each year, according to the relative plan, we have this. Okay? But for absolute classification, we cannot have this. It depends on the level of vulnerability. We compute the level of vulnerability and we compare the level of this vulnerability by the threshold. I don't know if you understand that. Exactly, it is a standard filter. We have so this difference among this way to classify the level of vulnerability. I don't know now if okay, so it was our last slide, relative classification of vulnerability in 2018 and 21. So here we have conclusion what we can keep on mind. Here we have 4 points. We can say the objective, our objective here was to carry out an assessment of household vulnerability to climate change in Rwanda, okay, by using 2021 CFSBA data. To this end, our methodology, we developed a composite household vulnerability indicator from integrated result framework for climate action in Rwanda and guided by the conceptual framework of IPCC report. The third point is the result obtained according to this exercise. The result obtained allow us to make comparison of the level of vulnerability of household between districts in Rwanda and identifies the factor of which indicator explains vulnerability. So in terms of policy, this result can contribute to better identify priority targets in the context of implementation of national adaptation plan for climate action development. So it is the last slide of my presentation. Thank you.
Thank you so much, Samba.
Okay.
This looks like a meetup, but it's digesting them. So I will open the floor for this presentation. So it's good news that, as I said, we are here. It's a only seminar, so still really have a program. But let's open some minutes for exchange and see if I can. This is my close neighbor. Then Dr. Vicky.
Yes, but I have a question. Compare 2018 one data. So can this be biased, if I may say, depending on the questionnaire prepared for the 2018 and 2021? Because the 2018 questionnaire was prepared by the consultant, if I may say, on the view of what we need in general, and then we approve that. But for NISR, that was different questionnaire.
Yes.
Is it comparable when you don't use the same questionnaire, same question? That's tackle. Maybe the last time it was in energy, then this year it will be in, for example, vulnerability flag, or it's something else to have. So will it be really same to you, or we need to have, if you need to compare the impact to time? I'm asking this because in Rwanda we're supposed to do the vulnerability index assessment every 4 years. So that is under according to the regulation in the law. So the last one was 2018, and then this one it will be done this year. So do you think that impact the information, because the last information cannot be the same information today?
No, it's you. Yeah.
I can answer it.
Yeah.
Mitigation, or I can directly answer.
Let's ask the question.
Okay, I ask if I can.
Did you not?
Yes, I know.
Okay.
I just want to get more question. On the result presented by the first month. Where you getting the saga as the most available, but I've seen the other districts. And next, you said the experimental indicator where the flood and the drought. Is it wrong? The indicator explaining where drought. The experimental indicator.
For the exposure, or the exposure component is the drought.
The drought.
That explains more.
Yes. And the floods.
But you can bring on the slide.
The slide. Let's consider maybe the drought. The drought. If the drought explaining that in the vulnerability observed in Rwanda, Sagara, in the other districts.
Okay, I see. Okay.
Why am I the same as the Kirehe in the other district? Is the same? Is that indicator explaining that? No.
No, it's not the same.
Yes.
Might vary.
Maybe.
In fact, the question is.
Let me maybe try. Maybe if I understand it, it's just you have shown different categories. Yeah. Show this kind of thing. So he's asked, is there some like one showing what influencing most than the other? Or you have just made like the all, compare the all indicators and you just plot as like one single. You combine all the indicators, then you plot them up of the vulnerability of all indicators together. Or you just, for instance,
This is the question I wanted even to ask. You should show this indicator contributes to at what extent.
Yes.
This is the question is asking.
Yes.
Okay. Maybe to expand more, if for example, in found in the 18, the hybrid, which are the factors, which are the second explain.
Okay, I see. Yeah.
If it is flat, for example, I may suspect maybe the appearance of this region.
Like more in the east,
The
west,
general
and
assumption of the chart. So let's take to the two questions and then jump in the flow of the next round.
Okay.
Do we need the presentation to?
Just to explain more.
Someone to explain.
Okay, let me answer the first question. So for this question, I can say we have the level of vulnerability for 2018, and we compute the level of vulnerability for 2021. So for the comparison, at my understanding, we cannot compare these two results. Why? Because as I said at the beginning, we need to define which kind of vulnerability we try to which kind of vulnerability we are taking. And here, in order to compare these two results, we need to have the same indicator for each component. If we didn't have the same indicator for each component, we cannot compare these two results, 2018 and 2021. But we cannot compare these two results if we did. But I'm not sure if we have the same indicator or not. But if we didn't have the same indicator, we cannot compare. At my understanding, we cannot compare these two results. But for each result, we can do this exercise. We can try to see the classifications or relative classification, because we are in 2018 and we would like to know the level of vulnerability, but after that we will know also if we do the ranking of vulnerability according to the district. So it is the exercise that we can do for 2020 and 2021. But at my understanding, if we didn't have the same indicator, we cannot compare these two results.
Your first slide was comparing 2022,
Yes,
2018,
no.
20.
Yes, I
saw
see.
the difference.
Yes,
One has something.
Exactly. I see. Here for this result, I just assume that if we have the same indicator, so we can say in 2018, the level we have just higher level, and in 2021, some district move from high level to moderate level or low level. If we have the same.
What would be your advice? The advice to make a massive questionnaire that we use every time, or we change it more every single 4 years as we move forward, just to track the.
Yes, maybe after the data I can contribute, but for my contribution is, my suggestion is, for select indicator, we need to have some framework, okay? So if we have, for instance, if we decide to use IPCC conceptual framework, okay? Every time we will use the same indicator. And so we will harmonize, for instance, exposure component. We can say to compute the level of exposure, we just need to select these 4 indicators based on IPCC conceptual framework. We need to harmonize the select of indicator for each component. So if we do this work, or if we succeed this exercise, we can compare the level of vulnerability over the year. But for each year, if we change the indicator, it will affect our results. So We can know the level, but we cannot compare these two levels.
In ideal condition, the ideal condition is having the same indicators, total years, and all these things. But it's also possible to have some level of variations in terms of indicators, as long as we normalize them, because we normalize them in any way. Whether you include, for example, 10 indicators or 12 indicators, then you are dividing it by the number of indicators to come up with the index, the actual score. So I think as long as Samban says, theoretically, they are very much related to vulnerability. I mean, that indicator has to be, at least, I think to be more technical is the latent variable. Latent means that unexplained variable is vulnerability, the damage. So the indicator we choose has to be, at least theoretically, very much correlated to the vulnerability. Because you cannot bring something, the number of flies here, and then correlate with vulnerability. No, I mean, it has to be like drought, it has to be flood, and all these things. And also follow the same classification: exposure, sensitivity, adaptive capacities. And if you follow, and we do some minor changes in terms of the indicators, I don't think that will bring significant change. So somehow it's possible. That's why 2018 and 2021, the indicators are different, for sure, because you say the questionnaires are different. And we just presented here, included here, with different data sets. It's consistent, actually. You'll see that your survey this year, and you'll see what will be like. In some districts, there is some inconsistency, but at national level, it's really consistent because the indicators were properly selected. Even if they are different in terms of numbers, they are theoretically highly correlated with the latent variable, which is vulnerability. So that is the idea. But the ideal condition is when you have the similar indicators.
Okay, thank you for your contribution. So for this question, it is important, and I understand why you asked this question. But what I would like to say, we have two information. We have the level of vulnerability, and after that, I do a classification or categorization. It is two information, but two different information. The first information give us just the level of vulnerability for each district. And I show you the map. According to the level, I said at the end, the three districts who have less level, the less level of vulnerability, I say it is just the three districts, okay? This analyze, I did this analysis based on the level of vulnerability. But after this part, I can say for the country, I just need 4 classes. I just need to identify which districts are much more vulnerable. I would like just to know which districts are more vulnerable or which districts are low vulnerable or much more vulnerable. I just need 4 classes. And so to get this 4 class, I need to develop another way. And to get this result, I develop the relative, okay, the relative or the absolute categorization. So in this categorization, you can see the 3 last districts who are less vulnerable will be, you will find this district in the first class. In the first class, in the district where, in the district is less more vulnerable. I don't know if you understand, but it is true information, but two different information. We have the level, we represent the country, the district according to their level, okay, and we did the ranking. But after that, we said just we need just 4 classes, or we need just 2 classes, we need just to identify. We can say we just need to have 2 classes according to the rest. We just need to identify which districts are vulnerable and which districts are not vulnerable. And we have to identify just 3. It is just some way to identify. For our case, we said we will build 4 classes: much more vulnerable, less vulnerable, and much less vulnerable. And so, according to this way, we try to classify the district by the level.
But he marked on the indicators.
Huh?
The indicators.
Yeah, no, it is for me. It is the first question, and now the second question is about the indicator. At my understanding, we have two information. We have the district level information and we have economy-wide information. So what I show you here is the economy. I explain the result. I show you the result of exposure, for instance, and maybe I forget to show you that it is. I try to see what explain exposure in economy-wide level.
Yeah.
Okay. But after that, in our paper, we will find for each district what explains this exposure, and it can change according to the district. But here I show you just in economy-wide what explains exposure. But I know it can be different from district to district. So in our paper, we will find for each district what explains more, what explains more the exposure, what explains more the sensitivity, and what explains more the adaptation interface.
Thank you so much. Thank you so much, Lavan. Thank you so much for this interest in the audience. So do you have other questions? Otherwise, you can have another presentation.
Yes.
Go ahead.
So maybe because we talking about economy, but we were discussing, because we saw the first slides you mentioned about flooding. So I wanted to know about the impact of the flooding on this kind of vulnerability, but you say it is about economy.
Yes.
Because the reason I want to ask, you say flooding, but I want to know what kind of flooding, what type of flooding. Because normally, when you do this kind of vulnerability or sustainability, people they say sustainability, I mean, how do you call it? Vulnerability and susceptibility.
Susceptibility.
Yes. So I'm familiar with susceptibility. So maybe for next time, if you go in detail, you should also consider the types of flooding. We have like river flooding.
Okay.
We have urban flooding. We have flash flooding. So maybe those types of flooding would result in different impacts.
Yes,
but when you take it in general, flooding, you are missing many information. My recommendation, next time if you go deep, you can just think about the types of flooding.
Try to disaggregate. Yeah.
Yes.
So you can disaggregate.
Probably this is important for the ERIC exercise. I mean, it's just like having a single indicator flood. I mean, just like asking the household, have you been exposed for flooding or not? That is the question we have. Rather than saying that, have you have flooding for river flooding or surface flooding? I think you know it very well, the name. So you can't have like disaggregate the but it's also, I mean, to mention also because you reminded me something, because this is just a knowledge sharing. It's also important sometimes have a weighting index, because the number of people affected by flood might be very few, but the cost is very high, including life. We are paying also life. Drought is okay, but I mean, for drought, it might affect a lot of farmers in Rwanda, but the extent of impact might not be as severe as with flood. So in that sense, I think maybe this is for improvement, methodological improvement. So we may need to have some weighting, but this time we are just weighting equal. But maybe for future exercise, flood might have to weight more than the drought, even if in terms of area coverage or household coverage is high for drought, but the damage is really serious. That might also be, that's something that you remind me. But sorry, yeah, I mean,
Thank you. So, we have another question, otherwise we are trying coffee to exchange notes somebody. So if there are no other questions, I mean, no burning questions, we can proceed with the next presentation, I mean, the last presentation by Dr. Henry. Yeah, so
we have the papers.
Welcome, Dr. Henry.
The presentation, we do have notes.
The presentation is about the economic impact of mitigation.
This time I'm not disturbing you.
No, please. I enjoy the cost. Yeah, it is about the economic impact of mitigation pathways in Rwanda.
So thank you, Mr. Moderator.
And let me say thank you to everyone for the very robust contributions that we got from the first presentation. So this one is about the twin policy intervention measure of government. The first time we talked about adaptation, so it's about mitigation this time around. Now, we know very well that the Rwanda government has performed very well. So due to good leadership, focused leadership, the country has experienced tremendous growth. But there's what we call the burden of growth. And when it comes to climate-related issues, the problem of emissions usually are contributed. Reason being that production historically is so, like I was saying, production historically is powered by energy, and most of the energy sources have a heavy carbon footprint. So the question now is, how do we minimize that burden? And that is the question of mitigation. How do you reduce the emissions footprint of the economy? How do you combine the goal of economic prosperity with the pursuit of an emission pathway to net zero? So these are the key questions. But that's not all when it comes to the economic questions. So there's an assumption we made here, again historically, that growth is closely associated with greenhouse gas emissions. But there is an unanswered question, and it's an economic or statistical question. Is there really a correlation between greenhouse gas emissions and economy? So that's debatable. But let's see what the data about Rwanda is saying. In 2019, the GDP of Rwanda grew by 7.4% from the previous year. Measured in US dollar, the economy went from $9.64 billion to $10.4 billion. At the same time, carbon emissions grew by 1.3%. That tends to give the impression that there is a positive correlation. So, now, I picked up this data from REMA website. It's the carbon change portal, or sorry, climate change portal for Rwanda. And that provides the most recent data we could provide for emissions. And it looked at the different sources of emission. From the energy, we have about 2.6 million metric tons, million metric tons. And then the IPPU, industrial processes and product use, about 0.15 metric tons. Our follow sector, as the agricultural sector now, is 4.29, and then waste 0.91. Effectively, this shows that energy is the second highest source of emissions when we look at broad sectors from this data. So that is the government data that we have. And then from climatewatchdata.org, we also got this emission profile for Rwanda. We see that there's an upward trend from 1991 to 2019. Keeps going upward. Actually, I found another one to 2021. It still shows an upward trajectory. It shows that the problem of emissions is not abating when it comes to the Rwanda economy. Yes, let's not talk about the relative contribution to global emissions, minimum. It's almost insignificant. But when we look at it in absolute terms, it's increasing. And so that means there is a job to be done by the country. So government has embarked on different mitigation measures. From available statistics, we see that in response to the upward trajectory of emissions, the country has made commitments to consciously reduce greenhouse gas emissions, so that it can contribute its fair share to the reduction of the global problem of climate change or climate crisis. Rwanda is approaching this through two major means: the conditional and the unconditional commitments to reducing emissions. For the unconditional commitment, it's a promise to reduce emissions, total emissions now, by 16% between 2050 and 2030 when compared to the BAU values. While if there is external support, this time funding support and technical support, but mostly funding, it has also committed to an additional 22%, meaning that the total commitment combined is 38% of emissions reduction by 2030. That would be a huge leap when we talk about the road towards net zero. So by 2030, hopefully, to be 38% down of what it was at the start of that pursuit. So this study, what we are doing here is again to do an economic simulation analysis to look at the mitigation pathways for Rwanda between the period 2021 and 2030. So the baseline here is 2021 because we are using the data set we are using is 2021 data, which is the 2021 social accounting matrix for Rwanda. So the study utilizes the standard applied general equilibrium. This was developed by Ofona Ismail, many of you may know him. It's a dynamic recursive CGE model. So it's unlike what we use for the adaptation, which is a static CGE model. And we can just provide a brief description of the model that we use, and we'll skip a number of things so that we can save time and spend more time on the results. So first, the model is structured into energy demand and supply side, but the focus is more on the energy demand side. It's not as if we ignore the supply side, or we're more interested in the demand side. And then second, model is focused on emissions by energy products and emissions by production factors. The third one, the production block of the model, follows a netted structure. And this block represents the defining peculiarity of the standard CG model. The model accommodates or can accommodate different energy types. So that's because we have in mind an energy transition agenda for the economy, where the government may opt to switch from dirty sources to cleaner sources, like petroleum oil. We can move to renewables that are safer in terms of emissions. Now, the combination of each energy emission bundle follows the input-output fees complementarities CS functions. Now, there's substitution between energy types, so it's not as if they are mutually exclusive. We can actually combine them and how we bundle. So when new energy technologies come up or emerge, you can actually drop some of the old one and embrace the new one. I think that's a realistic assumption. Then the other thing about the model is that the idea of an extended value added is built into this model. And we'll soon see what that means. It has to do with the way energy was treated. Instead of intermediate demand, we are treating it as an input form of energy capital. So unique characteristics. So the interesting thing about the energy as a production factor in the standard CG model is that it is consumed within a business cycle. So even though it's a factor or an input, it has its own unique characteristic within a business cycle. In economies, that cycle takes place mostly in a year. So you consume it. So it can be destroyed within that cycle, unlike the other factors that you consume within multiple business cycles, such as labor and capital, that extend beyond a year, you keep using it. But this one goes with production. Now, finally, the extended value added is combined with intermediate consumption to produce the aggregate output of the economy. Data sources. So again, I said it's the same sum we used as what we did in the adaptation study. But this time around, we had to do considerable sum adjustment because of the way energy is treated. And so we still have 41 sectors and 41 commodities in the model. Labor and capital are the core production factors, but we adjusted the sum to include energy capital as part of the production factors. And that's combined, the three of them give us the extended value added components. The households are still the same, 10 representative households. Other economic agents include firms, government, and the rest of the world. The sum captures three tax components. So that shows the income or the revenue of government. We have direct taxes, import taxes, and sales tax. So there are no product taxes in this time. So in describing the data source further, we'll just look at the structure of the economy based on the sum that we used. So here the trade structure of the 2021 sum, we see the different components. If we pick GDP, for instance, we see that agriculture contributes 23.5% in 2021. Other industry, so what we are calling other industry here is the industrial sector, net of manufacturing. So other industries, 17%, manufacturing 8.4%, and services 51.1%, meaning that services is very large in Rwanda. Then if you pick exports, you can just read it like that. Agricultural export is 12.9%, and so on and so forth. Then the production structure based on the 2021 sum, again, the same way we looked at it, agri contributes 37.4%, other industry 17.9%, and then manufacturing 9.5%, services 35.1%. So if you look at it by the row, the share in value added, for instance, labor has 49.0%, fiscal capital 41.4%, while energy capital is 9.6%. So that's the extended value we talked about. Simulation scenarios. We have 4 major simulation scenarios for this study. The BAU, then Sim 1 to Sim 3. So the BAU scenario is the business as usual. But the others, we divided them into 2, to group them into 2 components. So Sim 1, for instance, captured the unconditional emissions reduction scenario based on the commitments of the Rwanda government. But the way we looked at each simulation scenario here is to look at a gradual implementation approach, and then the other one is a more aggressive simulation approach. So the 16%, we envisage a situation of implementing it gradually between 2021 and year 2030, while the alternative is to assume we don't have all the time in this world for decarbonization of the economy, so we reduce it to 5 years between 2021. This was 2026, so both years inclusive would be 6 years. So that was what we did. And for each of the simulation scenarios, the Sim 2 is treating the additional commitment of 22%. Again, broken down into gradual implementation and aggressive implementation. While the SIM 3 is the combined target, implement everything at the same time and see what the impact will be on the economy, again, gradually and then aggressively. We begin to present the results. First, we looked at the energy intensity of GDP, variations from BAU. So what this shows is that the energy intensity will drop across all simulation scenarios. So what exactly is energy intensity, so that we'll have a working definition of that. So it is the measure of total energy cost of per unit of GDP. Or another way to look at it is, on the average, what does it cost to convert energy to output? So you simply just divide the energy required by the output level of the economy and see the average there. So that will be declining as we progress in time across all energy sources. So between 2022, which is the projection period, up to 2026, we have the 6 scenarios. But beyond then, we have 3 each. And the reason being that the aggressive implementation approach terminated in 2026. So we now have just the others left. But they all decline. If you look at SIM 3A, for instance, this one, okay, it shows that if you engage in the combined targets, 38% reduction, it's going to bring down the energy intensity of GDP. So that will be much more beneficial for the economy. Now, we are not looking at the social cost of doing that. I know it may sound very unrealistic to some people to say, oh, you are reducing emission by 38% at once. It means we just abandon all the traditional means of production. But it's a scenario that we feel should be looked at. So that one shows that it will be very, very healthy for the economy and it will move fast. But how the society will accept that, the model doesn't have an answer, whether that's acceptable or not. And so that's the picture we see under the energy intensity of GDP. Next is the emissions intensity of GDP, which is actually a measure of the efficiency of use of carbon-based products to produce in the economy. So how efficient is the economy utilizing the different energy sources? So again, as this one is reducing, it's more healthy for the economy. So it shows that the share of emissions per output per $1 GDP also is actually reducing. And that's good for the economy, it's environmentally beneficial. Again, what we see in this result is everything declining across all simulation scenarios. So that for us is a good development. It means if these scenarios are implemented, then we expect the outcome to be beneficial to the environment in Rwanda by different measures as indicated in the results. So now we move to the economic side. So we have left the environmental side. We see that it's beneficial, it brings about efficiency in the use of energies. It's healthy if you transit from one energy source to another by reducing emissions. But for the economy, what happens? Real GDP, again, will decline. And that decline will become very pronounced as we progress in time. Initially, the economy may not even realize what is happening. But as you move from high carbon source and carbon energy source to low carbon energy source, then we begin to see the implication much more pronounced in the economy, and the decline becomes sharper. So that real GDP, for instance, will decline seriously from the white peak now. So during the first year, 2022, we see the negative impact is expected to vary between 0.11% and 0.13%. But if we now push that up to 2026, then what we are seeing is much more than 2%. So that's a significant decline. Again, it's when compared to PAU value. Now, looking at the impact on total investment in the economy, again, it will change, it will decline. Investment in this will discourage investment dramatically. By the time we begin to implement an energy transition agenda by reducing emissions. Because when we say, I need to just comment on that or say something on that. When we say we are transiting or we are reducing emissions, it doesn't mean we are not producing again in the economy. What is assumed here is, instead of using fossil oil, you are using more of energy sources with less carbon footprint. So you are transiting more towards renewables. And so investment in the economy is expected to drop once that is pursued within this simulation period. And emissions reduction impact on agricultural value added. So we have 4 broad categorization of the economy. So we look at the impact on the value added for agri, for manufacturing, for services, and then for other industry. So here we see everything dropping. If you look at year 2030, for instance, the greatest decline in percentage variation of agri value added is expected when you compare that with PAU. So we see it dropping by about 1.47%. So that's a problem actually for the economy, that when you transit from one energy to another, we see agricultural value added keeps declining and declining and declining. And if we look at that of services, yes, it's not as sharp as that of agri, but again, it's the same pattern. Everything is declining. From the first year, as we progress in time, it becomes more pronounced for the economy. For manufacturing, similar pattern. So this is the result we saw, and we try to make sense out of all of this to see how this fits into the commitment of the government to reduce emissions, and then the desire of the government to seek external support. The model shows that the emissions reduction agenda of government will, even though environmentally beneficial, be economically damaging across sectors, whether it be the services, agriculture, manufacturing, and industry or other non-industry. But we also saw that the manufacturing sector will be worse affected than every other sector in the economy. I think that's an important finding of this study, that the other sectors are less affected than manufacturing sector. Maybe this could be explained by the heavy dependence on the manufacturing sector on the different energy sources that we focused on in this study. Remember that even though agriculture is a major source of emissions in the economy, the study didn't focus on agriculture, but it's on energy, the different energy sources. And the result simply shows that the manufacturing sector will suffer the most when compared to other energy sources. And so by way of summary and conclusion, the results presented indicate the potential for immense environmental benefits to the economy arising from an implementation or the implementation of an emissions reduction agenda by the Rwanda government. But the economic benefits, the model does not show much economic benefit coming from any of this, from this agenda. So what then does that mean? It's simply, we can say that these results can actually help justify the need for government to invest, for massive investment into the economy, so as to be able to mitigate against the expected negative impact on the GDP. And in addition, this result also justifies the need for government to be asking for external support under the additional 2% conditional targets. Okay, that since this is going to affect the economy adversely, and the Rwanda economy is expected to suffer immensely by this particular agenda, energy transition agenda. And again, if we look at it, we cannot claim that any of these developing countries really is behind the global climate change crisis that we see today. I think the richer nations, it makes sense to ask them to take a share of that burden of transiting from fossil-based energy sources to cleaner energy sources. So, where it is recommended that the emissions reduction target of the government should be vigorously implemented. It should not be abandoned at all levels of the economy, given the immense environmental benefits. But we also want to know that the gradual implementation approach should be more realistic, in this case, to allow the economy enough time to adjust, so as to avoid some kind of social fallout that may come up if the government goes the aggressive route. And then, in view of the expected decrease in key macroeconomic variables in the economy, government should mobilize enormous domestic resources that are pursuing an appropriate carbon pricing framework. So this one, based on what we did, the assumption was that government provides carbon credits to the entire economy, which is a realistic one. What that means is that even though there are sectors that are polluting in this economy, we simply provided a column in the social accounting matrix that shows that that is, they don't pay a price for that. So sectors that are polluting for now don't pay anything. There are no sanctions for polluting. So that's equivalent to carbon credit. And so we are recommending here that an appropriate carbon pricing framework would be useful in mobilizing domestic resources to fund the energy transition agenda or policy of the government. Then the other thing we also want to recommend here is that foreign investors may actually be encouraged to complement the domestic investment to be provided by the economy. And how would that happen? Tax breaks. That's a good way of encouraging those that want to invest in the renewable energy sector to do so. And then government should also, another recommendation, arm itself with findings from evidence-based studies, such as the current one, to make a strong case for external funding support from its international development partners under the conditional emissions reduction target. So when they are able to show that the reduction agenda will damage the economy severely, then that can actually be a justification for richer nations to partner with the government to achieve the global goal of emissions reduction and then mitigating climate change. So on that note, let me say thank you for your attention. So we welcome comments to improve the work.
Thank you so much. Ready? So, do you have some other questions? Someone has a question, can you ask? Yes, something true.
Yeah, just yes, some clarification. The whole idea is how the set targets by the government of Rwanda, the 60%, the 50%, the 38%, can really have impact in the economy. This helps for the country to negotiate on the international climate deal, because this is how much our economy will be affected. This is how much. If we have to achieve these targets, yes, we committed, but this much is our economy being affected by this implementation. So it's up to the international community, because I know this carbon is not a global, it's not a national commodity, it's a global commodity. Then we have to be compensated for this much. And we need somehow some investment, additional investment. So from our side, from analysis and data analysis perspective, I think we should go further and add one more scenario and see what type of, how much investment and what type of investment can really reverse this impact. The same we did for adaptation. So then you have to, I mean, we have been discussing, what is really the correct mix of energy that can really minimize the cost in the economy, because how the energy transition has to be done from dirty to clean. And there are some issues that has to be done from our side, but this is a preliminary analysis. We have we initially, but still this analysis for us is very important, because it can help for the government to raise this into the climate deals or negotiations. That is the whole idea behind this analysis.
That's very helpful.
Okay.
Yeah, thank you so much.
I saw that you discuss about energy. It's only the energy sector that in this. So what will be the impact of other sectors? Because now the contribution, the main contributor sees more than 4,200. But you took the energy to this. Why did you choose energy and culture? Why it is the one that impacted the world?
But it is a powerful comment or question. What my colleague has said. In fact, we focus on energy. Here and we have a different sector. It means a sector. And at the end of the make the conclusion. So I'm asking you, are you going to consider the sector then to come up with a general conclusion? I'm trying to read one of the conclusions stating the economic benefits. So can we make a conclusion based on one aspect of one sector, or I like the different conclusions. For me, it is really informative for the policy makers. But I think it would be better to consider also other sectors.
Yeah, because when we are doing this on energy, the scenario is to reduce the 38%. And then the 38% is counted from all the sectors. It's not all on energy, so it's better to have almost all the sectors, so that I think the effort will be more relieved from energy and the other sector. It's much somehow easy not to just focus on energy, but much focus for the food culture, for example, forestry and waste and industry, which is very small. As we will grow, I think the industry will grow as well. So how to mitigate that, how to cope with the green industrialization to reduce our emission, maybe that's also something that useful to have to tackle this.
Then you can take the question. Then you can just tackle those two.
Thank you. And thank you for the comments. Geta mentioned about additional scenario to be introduced. I think that will be taken care of as events unfold in the course of time. Then the second person asked a question, why energy and not agric sector? Since agric is the dominant source of emissions in the economy. Well, we provided these results because we know that persons seated here are aware of the relative importance of each sector, and then because we are also aware of it. But by choice, we concentrated on energy sector for obvious reasons. Energy is used by almost every sector of the economy. You see, it's an input, whether you call it intermediate or direct input. It's used by almost every sector. So if we model energy, we practically touch on every other sector of the economy. Agric, if we pick agric, then we look at a single sector, and then we have to start tracing the linkages to see how that impacts on other sectors. So given these two options, we pick the one that directly affects every other part. Now, the other reason why we also elected to use energy, to focus on energy sector, is because agric is much more sensitive, politically sensitive. Remember, if we want to reduce emissions in the agric sector, then you touch on a very sensitive part of the society, because you have a very weak and vulnerable people operating there, and you want to block their means of livelihood. So that becomes a problem. You have many more problems to manage. So in our opinion, why not tackle it from energy first? That is easier to deal with. You can quantify it, I mean, in terms of how much emission to cut off. You know how to target it and drive it, than going to the agric sector to begin to prevent certain practices that you know will contribute to emissions. So those were the things we thought of, and we said it's safer to start with energy. Maybe in the course of time again, it can be expanded to look at how to approach it through the agric sector, the major contributor. Worldwide, actually, many studies, or even governments, try to minimize tackling the emissions reduction issue through the agric sector, because, you know, they say a hungry man is an angry man. So if anything goes wrong, you may find the system ungovernable. So we feel energy sector cuts across everywhere, and it should be the starting point. Then better to consider also other sectors. I think that has been 38% is for all sectors. A very important comment. I thought of it also, but we cannot deny the fact that the energy sector is also very significant. And remember, as the economy continues to expand, you will see that every other thing within the economy pivots around the energy sector, including the agric sector. So if the country is able to drive it through this, whatever happens there can speak for the rest of the economy. That's the way we see it. And remember the recommendations.
if you want to really mobilize domestic resources to fund mitigation, it will be easier to do through the energy sector. Just introduce a carbon tax in the economy so that the emissions, the polluters get to pay for their pollution. That's very difficult to do in the agri sector. So all these things were considered and weighed before we actually energy sector. And moreover, the adaptation sector will focus on agriculture. So first energy should also be looked at here. Thank you.
Thank you so much. So if you have other questions or inputs or comments? Yeah. So we went from Propomi to others now at the mitigation to stand model. So
She has a question.
Oh, the question. Oh,
Yeah.
go ahead, Pat.
I may have missed it in your presentation. I wanted to know the mitigation. But and we have missed it because
Mitigation pathways.
Yes.
Are they there? In your presentation, have you talked about mitigation pathways?
Oh,
Yeah, you know, what mitigation pathway.
so when you look at,
Energy sector, which one?
yes, when you look at the different scenarios, so these are the pathways that we considered. The unconditional targets or commitments, the conditional commitment, and then the combined commitment.
But you referred to those in the
Huh?
You referred to those in the context. The unconditional.
Yes.
That's the current.
Okay.
I think it's a good, like I agree with others, if we get other sectors.
Yes, the study can be expanded to, but it will be very, very involving. The task can be involving, but do it.
Yeah, I think this is to the best of our understanding, this is the first initiative to the model mitigation in terms of economic model. No, it's not like it. Yeah, we are struggling even to learn with us. And we had, if I remember, I think 2 or 3 sessions, brainstorming sessions with us and with Usman and with all resource people. And Ismail Fofana, he was with us. He was supporting before he did, and he's the one who developed the model. And also still we are not really that much happy because the policy implication has to be very clear in terms of, especially on the energy mix. What is the optimal energy mix that harm the economy less? That is the research question we are looking for. But I don't know how to do this, but it's a good progress we are making. Thank you. On the pathways, I think this terminology is just like coming again and again. For us, I mean, we might be wrong. We might be wrong. When you say pathways, we are referring to the scenarios. Yeah, we are just referring. Scenarios, based on our experience, our scenarios are more of operational scenarios. For example, if you look at the UN institutions, including the IPCC, the one I think you shared with, they have different scenarios. The UNEP, the UNEP, and there are now scenarios for the planet for the coming how many years. I was part of the task force, and that one is a strategic foresight. They are just predicting what will happen after 20 years, 25 years, 30 years. It's just like given the current system without any interventions. But for us, our pathways are, if the government does this, what will happen? If the government does this, what will happen? This is how we set the pathways. So their pathways definition, scenario definition might be a little bit different from what we are defining. We are just looking at from policy perspective. What if the government do achieve like the 60%? If the government want to achieve the 20%, if the government achieves both, and what will be the outcomes. That is how our pathway and rapid and implementation and the other one, gradual implementation. These are the pathways. But if you look at these pathways compared with the UN institutions pathways, they are not the same. That's why people become confused, get confused when you say, yeah, they call it also pathway, we call it also pathway. They call it scenario, we call it scenario, but in actual sense, they are different. Ours is more on the policy. By the way, Academia 2063 is a policy research institute. And so we always predict what if the government does this? What if the government? We are not predicting what's going on in the environment, and simply this natural way of things, the way the UNEP is doing. So I just want to prove that, because I have been asked several times about pathways. Where is the pathway? Even the REMA DDG, he was asking me how really set these mitigation pathways. And it's complex, I would say, he is right.
Maybe also I can just advise you about, of course, the inventories. REMA have been done a lot about this kind of emission different sectors. But also there are some modeling the data that many countries they use. Oh yeah. And they provide a very, very deep insight across many sectors as possible that even we don't have in Rwanda. Yeah? For instance, you can, I've been doing this kind of research, but I didn't go in deep in details. Maybe if you have time to go through, there is a model called EDGAR, Emission Database for Global Atmospheric Research, EDGAR, like a name, EDGAR. So even now, I was just picking my data here. I have a lot of data of EDGAR here. So we have like power industries, the emission from power industry, combustion from manufacturing, aviation. So we have energy for building, we have solid waste, we have wastewater, we have agriculture, waste burning, so many things. So you can use this kind of.
Yeah, these are model outputs, yeah? Sorry? Model predictions, yeah?
Yes, yeah, they are the model that from 1970. 1970, so more than 30 years. There are many data available.
Those data are, for sure, they are there, and they will be important to, I don't know, to define optimal mix, because from different sources, the emissions are different.
Yeah, the optimal mix question, remember the CG model uses just a long period data set. So in this case, it's 2021 we are using. Okay, but we were close to actually answering the optimal mix question, but there was a glitch in the model that didn't allow it to work. I had that discussion with Ismail. We have to engage in a phone discussion on that. So hopefully we'll get to interact more on that to resolve the problem. But we couldn't do it because there's an energy fund already for Rwanda. The data is there in the SAN. We're able to break it down using the US EIA, Energy Information Administration. That was the source of data for that. But there was a glitch in the model, which we will fix later on, and then answer the question on optimal energy mix.
And also we'll use this data. We'll check it here.
Yes, yes, as a supplementary data.
Thank you. So
it's just a request. I think it is important that if you have plans to share with us, for us to go more detail. There's a presentation that is just a full report.
Yeah, I think immediately we'll share the presentations. Sure. But the full report we have to share officially with REMA. That's our partner, and then we'll share all the reports presented.
I think the presentation we need to share to everyone, for reference, for understanding.
Let's first share for you.
Some of us who are here will not reading there.
Okay, I think we can do, we don't have, we already have the draft.
So I think with your draft, it's no, it's, for now, it's not yet a draft. I think you will send the draft after the article, the comments that has been.
Oh, probably, yes, you are right. We have your own emails and we share all the reports we have. And then you can give us the comments.
Yeah, I think that would be good.
Then we revise it. That's also a good idea.
People presenting this, we can share the, after incorporating the comments and adding more what you get from this discussion. Maybe you can share it for everyone. In case someone need to get to give the comment or add something or request input, so that you can, after at the end you say it's the final, then you can share.
As I put to again, by leaving time, some are immediately on the products and that was made by a bank that are really ready to go to, but others need some tweaking. So, but what you have ready now, share the presentation ready. Yeah, that long reports like the vision does, some teaching, some that sharing sometime the coming days. So otherwise, really nice to thank you for the opportunity that was given to moderate the session. I'm not having much to say. This was really a seminar. We exchanged to learn about Edgar, the models, staff models. But let's keep in touch. Let's keep in touch. As the MD said, we are here to stay. So let's see how we can support. So we have a lot to do. Some maths.
Yes. Thank you. Yeah. Thank you, Serafin, and thank you, everybody. It was a very interesting session. And we are very happy for coming. And I think we get a lot of contributions. We are very glad for that. And it was also a very interactive session. I like it there. So I think thank you for everything. We were supposed to have a coffee break, but we didn't have it. But the group was waiting outside. So you can grab your coffee and chat, enjoy. And you can reach out at any time. We can have, this is the first initial, as I said before, this is a pilot program. We are based here in Kigali, Rwanda. So people might change, but academia will continue. I'm not saying we are going to change, but I'm not saying that. It might, the project might change, the people might change, but academia will continue supporting Rwanda. We have a reason to come to Rwanda because we have a very active involvement in African development discussion. And our root is back to the CADA party. Maybe some people know about CADA, the African Comprehensive African Agricultural Development Program, which is the African Union program. In that program, we have been supporting African countries, and Rwanda was one of the best countries performing on that exercise. So that's why we just came here, and we want to contribute something. And climate change is our new area of intervention. We had a very good experience in agricultural trade analysis. We have a very good experience in food security analysis, poverty analysis, market analysis, trade analysis, in all those state policy analysis issues. Climate change and nutrition is coming as a big concept for us. So our Dr. Aisha is for nutrition scientist, which is recently joined Academia 2063. So we are now just diversifying our interventions. Climate change, nutrition, food system transformations, and all these things. So we are happy to have you, and we will continue having discussion with you in different forums and different perspectives. Thank you for coming. Please enjoy the coffee. Thank you.